Hello there and welcome to this very exciting first video for cinematic lighting in Houdini. I'm Nick Chamberlain and I'm so happy you're here. I'm so happy you are taking this course. It's one I'm really excited to share with everyone. I think there's a lot of good stuff in it. So let's go ahead and hop right in and take a look at what we will be learning throughout this course. We'll just go through a quick overview before we dive into anything too deep. So when creating this course, I had three main goals at the outset. I wanted to show how to approach lighting a scene from a creative and cinematic perspective. What does it mean to light a scene cinematically? How do we compare it to when you are filming on set and they are lighting their scenes there? It needs to be both realistic, but also aesthetically pleasing. And that is often a difficult balance to get. So we'll talk about what that looks like. And then our second goal is understanding the technical process for lighting the scene within the context of a photorealistic visual effects pipeline. What does it look like when you have footage that you need to match the lighting to, but you don't have an HDR? What happens when you have an HDR, but it's not working correctly? When can I cheat my lighting, and when do I need to be bound by what the plate looks like? We're going to go over kind of how to approach these different types of visual effects shots. And then our third and final main goal will be to understand USD, Universal Scene Description. I'm a big believer that USD is the future in 3D. Most of the big visual effects studios are doing a lot of research into how to incorporate USD into their pipelines. And I think it's really a good time to start learning it, start understanding exactly what USD is and how it operates, because it is quite different than working just in standard 3D. A lot of the terminology overlaps but means different things. If you've ever looked up any of the documentation, you'll find that it's often very technical and hard to understand. And so we're going to be looking at USD through a practical standpoint. We're going to go through what I think are the most confusing concepts in USD and make it very clear what they're used for, why they're important, so that you can know when to implement one USD concept over the other. And we are going to be learning all three of these main goals through Solaris in Houdini. Solaris is the most advanced USD authoring tool that is publicly available. And I think Solaris is a ton of fun to use. There's lots of cool tools in there to kind of help your lighting workflow. And something I do want to stress is that while learning Solaris is certainly important and is a huge focus of the course, I do want to stress that at the end of the day, Solaris is a tool, and understanding the underlying concepts of these three main goals is much more important to me than understanding Solaris. And that's not to say we're not going to learn Solaris and understand it by the end of this course. We certainly will. But knowing these three main concepts will take you so much further than knowing Solaris ever could. Solaris is a tool, and we will learn how to use that tool and press the buttons. But these three main goals are really more about the why are we pressing this button? Why are we approaching it this way? And to me, that is just so important. So there will be a heavy emphasis on why we are doing what we are doing within Solaris. And so we'll hop in now to a weekly breakdown and just kind of look at the 8 weeks of this course. So in week 1, we are hopping in straight away to talk about lighting. We are going to do an intro to Solaris and USD Basics. What is it? Why is it beneficial? We'll learn some theory and cinematic lighting principles as we start to light our very first scene. I wanted to start with lighting because a lot of courses talking about USD, start with the kind of boring technical basics. They talk about the asset creation, they talk about layout creation, and it's not until the very end of the course where you can actually start making things look good. So I want to start there. I want to start from the lighting standpoint so that anything we're making throughout this course, you immediately know, okay, now I can take this, light it, and make it look really nice. I think it'll be more interesting to follow along that way. So that is why we are starting off at lighting. And then in week 2, we are going to go to the foundational building blocks of USD in basic assets. We're going to learn how to create optimized and efficient USD assets. We're going to talk about color space management, USD layering, composition arcs, and more. And this is really going to give us a nice foundation foundational knowledge of how USD works. Then in week 3, we are going to expand on our week 2 knowledge and use it to customize the component builder to suit our needs. And we are also going to learn how to procedurally create our own asset library and materials. Then in week 4, we are going to dive into shot layout. This is going to be kind of part 1 of our big CG shot. We're going to look at laying out that large scene with Solaris tools and instancing workflows. And we're going to look at how to look dev many lighting setups quickly. Then in week 5, we are going to continue working on that same shot. We are going to add our finishing touches to our lighting, to our layout, and then we are going to add effects to our shot and do some compositing. Then in week 6, we are pivoting back into lighting, and now we are going to start talking about something a little bit more plate related. Our lighting topic will talk about the technical process to correctly light when you have footage with HDRs. We're going to talk about spatial lighting concepts and what you can do really when you have everything you need to properly light a shot to footage. Then in week 7, we're going to take a look at the not ideal scenario. What does it look like when we don't have an HDR? How should we approach our lighting setup without any on-set photography help? And then finally, in week 8, we are going to take a look at sequence lighting. When it comes to lighting our spaceship sequence, how does that work when we're an individual artist versus a team of artists? How can we effectively collaborate in USD? How do we take maximum advantage out of this very flexible workflow? How can we essentially work on 5 to 100 shots at the same time? So we're going to take a closer look at that in week 8. So that is what it looks like for our weekly breakdown. And like I said, I'm really excited to show you guys what we have in store. And this course also comes with a few assets for you guys to use that are very exciting, because one of the big problems I had when taking lighting courses myself in the past is you're not really able to follow along because they don't have the rights to distribute the assets. But in this course, we do. We have 2 beautiful hero ship assets that you guys will be able to receive and use. And so those will be a ton of fun to light. We also have a pack of untextured buildings and sci-fi prop dressings that will take a look at procedurally shading for like midground background usage. And so those are really nice. We should have everything you need to build a really cool scene in 3D. The only thing that I'm not able to distribute is the close-up set dressing elements. I use some big, medium, small kits to do that, which I will show you right here. It's a really good pack. I unfortunately can't redistribute this, but like I said, these were for set dressing elements and for additional flavor. You don't need to purchase this to follow along to the course, but it is a really good pack and it adds some nice hero quality elements that look great in the foreground. And we're also including around 5 to 7 pieces of footage that was shot on an ARRI Alexa so that we can practice lighting with footage that was done with a professional cinema camera. And so I'm very excited about that as well. Let's go ahead and move on and dive into more specifics about what we're going to learn in week 1 in our next video. Thank you so much for listening, and I'll catch you in the next one. Hello there and welcome back. In this video, we're going to dive into everything we can expect to learn in week 1. So let's go ahead and get started. So the very first thing that we are going to talk about are the benefits of USD and Solaris. Why is it important to learn, and how can our lighting workflows benefit? Then we will dive into basic USD terminology. We're going to learn the foundational building blocks that are required for understanding USD. And then we will continue learning about that terminology by building a very basic USD scene. We'll be able to see how it's structured within Solaris, and we'll be able to bring in some really nice provided assets to start playing around with our lighting. And then we'll also look at how we can load in our own geo and materials, and we will also learn how to assign those materials to our mesh through a couple different methods and talk about the pros and cons of each type of assignment. Then we'll start to dive into cinematic lighting principles. This is a look at theory of how films are lit and achieve their cinematic looks through motivated lighting. We're going to talk about how to make it aesthetically pleasing and dive into all of those fun details. And then we will hop into Solaris, look at the lighting tools that we have in our tool belt in 3D to accomplish those cinematic lighting principles. And then we will go ahead and start to light based off of a story. We're going to look at using reference and our tools to create an image that satisfies our three primary lighting goals. And then finally, once that is all done, we are going to take a look at rendering our image very quickly, matching our color space in Nuke, and submitting our first assignment. So that is what we have in week one. I'm very excited to get to it. So let's go ahead, move on, and start talking about the benefits of USD in our next video. Thanks so much for listening, and I'll catch you in the next one. Hello there and welcome back. In this video, we're going to talk about the benefits of USD and Solaris and why we should use them. But before we can talk about the benefits of USD, we need to understand exactly what it is. So what is USD? USD stands for Universal Scene Description. The technical definition of it is USD is a comprehensive framework for storing complex 3D data in a single file format. A perhaps simpler explanation would be USD is a file format and a workflow that stores 3D scenes. And one of the big advantages of USD files is that they are universal, meaning that USD 3D scenes can be accurately loaded by most professional visual effects software. Almost all of the big players in the VFX software game have either implemented USD or they are in the process of implementing USD support. So exactly what 3D data can USD files store? USD can store geometry attributes, materials, animation, lighting, cameras, render settings, instances, and so much more. In short, it can store everything that you need for a 3D scene. It accurately retains all of your scene information. With USD, we could accurately load the exact same 3D scene in Maya, Houdini, Blender, or even Nuke for compositing. So just by defining USD, we have already exposed a major benefit. USD can accurately display its 3D data in most, if not all, professional VFX software. Imagine being able to send an asset from Maya to Houdini or from Blender to Maya without needing to worry about recreating materials, shaders, or your instancing setups. If you wanted to, you could even include scratch lighting that was done in your look development renders and then easily turn it off. USD allows a less painful workflow when it comes to sharing 3D data between our software. But USD is so much more than just a file format. USD is also a pipeline. It is a new way of working within itself that has many inherent benefits. The USD pipeline allows for teams to easily collaborate on shots and sequences without needing a massive VFX pipeline development team. Multiple departments can collaborate, share data, and update assets without interfering with one another. The USD pipeline allows for individual sections of a 3D scene to be automatically updated across a shot or a sequence. We can easily push an asset update across a large sequence of shots without needing to hop into every single project file and make an update. The USD pipeline also allows all of our 3D scene data to be constantly exposed and ready for modification. And we can also selectively control what updates we receive to our shot through opinions. It isn't like Maya referencing where we are appending files together. We can use stronger and weaker USD files to selectively load edits for specific shots. USD is also unlike Maya referencing in the sense where USD isn't really a black box. With USD, all of the data is exposed all of the time, and we can edit any aspect of our 3D scene that we have loaded without needing to open up separate files. We'll go through more examples of how the USD pipeline is beneficial later in the course, but these are the three broad strokes massive advantages when it comes to working with the USD pipeline. And another advantage of USD is that it is very efficient. USD can confidently handle complex 3D scenes and accurately display its data. USD file sizes are small thanks to its layering workflow. There is very little duplication of data that's required. The only data that is written down are your changes because of how USD works in layers. We'll talk about this more in detail in a later video, so don't worry if that is a little confusing for right now. Another advantage is that USD can talk directly to render engines, and this is a big efficiency gain for big sequences. So USD is more than just storing 3D data. It can communicate directly to render engines. Traditionally, when you're rendering, visual effects software needs to translate a 3D scene to your renderer of choice. Let's take Mantra for an example. When we create a 3D scene in Houdini and need to render it, we can't directly render from our 3D scene. The data in our 3D scene needs to be converted into a format that our renderer understands. In Mantra, this format is a .ifd file. This conversion file is our scene description. It describes the 3D scene in a way that Mantra can understand and render from. Most, if not every, render engine has some sort of intermediary format that the 3D scene must be converted to in order to render. They all need different scene descriptions. Mantra has IFDs, RenderMan has ribs, V-Ray has VR scenes, and Arnold has the strangely named AS file. Converting your scene into these scene descriptions takes time, and the larger your scene is, the slower this conversion process becomes, which makes our time to first pixel slower and slower. Now let's go to USD, Universal Scene Description. USD promises to be able to communicate directly with your render engine of choice, speeding up our time to first pixel because our USD file is already a scene description itself. The USD file can directly communicate to the render engine and skip that scene translation time. And that's also beneficial because if you've ever written out IFDs or AS files, you know that they can become very heavy and be potentially several gigabytes per frame. And that data gets very large very fast, and being able to directly render from a .usd file has a lot of inherent efficiencies, not only in time to first pixel, but also in storage. So these are the benefits and efficiencies that we can see with USD. But we have even more benefits because USD is very asset friendly. This ties in a little bit with how USD is universal, and we won't have to recreate assets and materials when going from program to program anymore. But beyond this, USD allows us to store multiple variants of the same asset in a single USD file. We can have different materials, different geometries, different levels of detail. We can have proxy geo that can be displayed when we're in OpenGL view and then automatically switch to high res when going to render. And we can also use the concept of payloading our assets to avoid loading them in memory until we need it. This is another concept that we'll go over in week 2 and 3 when it comes to building our assets. So there we have it, our 4 major benefits of a USD pipeline. USD can accurately display 3D data in most professional visual effects software. USD is a pipeline that allows for easier collaboration between artists, as well as efficiently pushing updates across a sequence of shots. USD is very efficient and handles complex scenes well, and USD is very asset friendly. And if these benefits haven't really convinced you that USD is worth learning, I have one more reason to try and win you over. USD is promising to be the new standard for 3D collaboration and work. And in my opinion, USD is the future for assembling and rendering 3D scenes in the visual effects industry. Almost all of the major VFX houses are heavily investing in the implementation of USD in their pipelines. If you're aiming to work in visual effects professionally, having a knowledge of USD is only going to be beneficial as the industry continues to adopt USD more and more. I anticipate that in the future, an artist not knowing how to use USD would be like having a compositor who doesn't know how to use EXRs. It's a format that has such great potential for increased efficiency and optimization that it is simply too important to ignore, in my opinion. Throughout this class, we'll learn the specifics of how to use the many benefits of USD within Houdini Solaris. Solaris is the best USD authoring tool that is publicly available, and it is able to take advantage of all of these USD benefits we have listed. In addition to being a fully USD-based lighting, assembling, and rendering suite, Solaris also has many quality of life tools that will help us light faster and more efficiently. So let's go ahead and hop into Houdini in our next video and start learning the basics of USD and Solaris. Thank you so much for listening, and I'll catch you in the next one. Hello there and welcome back. In this video, we're going to start taking a look at how Houdini uses USD in Solaris. So let's go ahead, hop right in, and make our first basic scene. So we have Houdini open here. Let's go ahead and change to our Solaris view. We're going to start off there for now. And also just a quick note, I have a few screen overlays. So if I start clicking, you'll know orange is left click, yellow is middle click, blue is right click. I have this drawer here that, it'll just allow me to highlight some things. And then I will also have a bit of a keyboard shortcut here at the bottom right. So if I do anything, you will know what I'm typing in. So just wanted to let you know that is going to be happening. All right, so let's go ahead and start bringing in some USD into our Solaris view here. And so in order to do that, I am going to create an asset reference node. And so we'll drop that in, and we'll see when we've created this asset reference node, our geometry spreadsheet has changed here. It has changed into the scene graph tree. As of Houdini 20, the geometry spreadsheet is intelligent and knows when we are in USD land here in our stage context, and will switch from the normal geometry spreadsheet that we know and love into this scene graph path. And the scene graph is going to show us everything that we have loaded up in USD on the currently selected node. But we don't have anything loaded in here, so let's go ahead and use our asset reference to bring in a USD asset. So referencing is one of two major ways that we load USD within a scene. Referencing basically means I am going to link to another USD file and bring in whatever the contents are. It's a shortcut pointing to another USD file. And this makes it very, very good for loading in assets. There are other nuances that we'll go into in a later video, but for now, know that referencing is the best way to load in an asset when we are starting to assemble our scene and bring in our individual components. So let's go ahead and click here to browse and find our USD asset. So I'm here with the folder structure that was included in the class. Like I've been saying, USD requires structure, and so it's very important that we try to follow the standards that are set within this folder structure. So we have an assets folder, V for vehicles. We'll go to bomber and grab the publish here, and we will load our bomber in. And now we have a bomber loaded into our scene. We can turn off this view right here, and we can just unclick, lock selection, click away. So we have our bomber loaded, and we can see our scene graph tree has now populated. We see we have this asset reference 1 loaded, and if we click this plus drop down, we can see there are additional folders. We have geometry, and then we actually have proxy geometry, which we can see here, and we also have render geometry. So this scene graph tree represents all of the data currently contained by the USD in our selected node. And Houdini also makes it very easy for us to inspect what our active USD looks like. What is this reference doing from a code standpoint? We can actually dive in and look at it. If we right click, we can go into LOP actions and say inspect active layer. And this is actually going to pop up the code that is running and generating our USD scene. So you can see the USD file is made of a couple default settings. We have our frames per second, the scale, time code, and then we can actually see the reference that we're loading in. There's not any geometry data in here. All we are doing is saying, hey, let's load in this USD file and let's put it in this location. This is just the transform that's saying put this at the origin, and so we're not currently moving it around. But this view allows us to see the actual code of our USD scene, and we can see the shortcut to that reference we made earlier. We don't need to know the specifics of every little bit and piece within here, but if you want to, we're able to dive in and kind of see what is going on under the hood in Solaris with our USD scene. And so if someone were to update the contents of this bomber.usd asset, we wouldn't have to load it in. We would automatically get that data pulled into our scene because we're just loading whatever is contained in this file. If you update it, this will automatically update. So I think that's something that is important to keep in mind and point out as we continue looking at USD. So what exactly are we looking at in our scene graph here? What do each of these lines represent? Well, each of these items are what USD considers to be a primitive. Primitives are the basic building blocks of USD. They are containers for 3D data. And this is often confusing because typically when we talk about primitives in Houdini, we are thinking of primitive attributes, we're thinking of actual polygons and mesh, but that is not what primitives are in USD. Primitives are a container for any type of 3D data. We can see if we expand over here, we have different types of primitive. We have mesh primitives. These contain our actual geometry. We have transform primitives. These behave like null objects, and if we were to move this transform primitive, everything underneath it would move as well. We have material primitives, and within our material primitives, we have shader primitives, and we have node graphs that have more shaders within it. Every single thing in our scene graph tree is a primitive. And here we have a scope primitive. Scope primitives you couldn't transform or move around, but they can store attributes that you can use later when constructing your USD scene. They are also often used as organizational folders, and it's just a nice grouping to put other primitives underneath. That's kind of how we're using it here. Primitive types define what kind of data is stored within this primitive. If we want to see a complete list of primitive types, we can quickly make a primitive node. And we can see here we have the primitive type. And if we just click this drop down, we can see all the different types of data that we can store in USD. And you could theoretically make an entire scene just by defining primitive types and setting their attributes. We won't be doing that because doing it with nodes is much faster and more efficient. But if you wanted to, you could. The most common primitive types have icons that are associated with them. So we know at a glance, these are all meshes, these are scopes, this is materials, and we'll see that as we continue to make more and more different primitive types. They have identifying icons that you can just quickly see what type of primitive we are dealing with. So all primitives need to have a name. We can see that the name of this primitive is geo. The name of this primitive is proxy. The name of this primitive is asset reference 1. And this is actually getting defined by our parameter right here. When we reference in a USD file, it asks us to rename the top level primitive. In this case, it is the asset reference 1. It is replacing the original primitive name that was here. So if we were to change this asset reference to bomber, since this is taking the name of the node, we can see our scene graph tree update, and now we have a bomber as our top primitive. And primitives can have the exact same name. I could name this glass in all caps. And once I expand this, we can see I still have this top level primitive named glass, and we also have this child primitive, which is also named glass. It is more than fine to have primitives that contain the same name. But primitives cannot contain the same namespace. But what is a namespace, you may ask? A namespace is the path of primitives that identify a primitive in the USD hierarchy. The namespace is our unique identifier of a given primitive. Namespaces are how we select, edit, and layer objects in USD, and that is why we can't have duplicate namespaces. So as a quick example, what would the namespace be of the energy engine? Let's change this back to Bomber just so it's a little bit clearer. All right, so our energy engine namespace would be bomber/geo/proxy/energy engine. And that is because it is the entire hierarchy of prims leading up to that primitive. So let's go ahead and see a quick example of how namespaces are used. So we can make a transform node in here and just connect that. We'll go ahead and take a look at it. And in order to select our energy engine, we can drag and drop the primitive into this primitives tab. This tells our transform node what we should be moving. If I give ourselves a little bit of room here, we can see we can now start moving around the energy engines. But if we were to update the namespace of our bomber, perhaps we put it in a parent primitive named vehicle, we can see that our energy engines snap back into place because the transform is no longer affecting the correct primitive. The correct primitive now needs V in front of it for vehicle. So if we were to update that, now our energy engines can move again. This is something that's very important to understand with working in USD. It's important to be very organized from the start because paths are not necessarily dynamically linked like the rest of Houdini. If you were to update this namespace, this transform does not automatically update as well. So it is of the utmost importance to make sure you are organized from the start when working with USD. So let's go ahead and apply this transform to our entire bomber. So we can do that pretty easily by dragging and dropping from our scene graph, or if we wanted to, we could also just delete the file path that we have here, and that will move our bomber. So, we can move him around a little bit. Maybe we can see where the ground is. And I want to take this as an opportunity to show you something that really frustrated me when I was first learning Solaris, because I didn't entirely understand the importance of unique namespaces. Now, let's say we wanted 2 bombers. If this was within SOP land, you could very easily make a merge. And we'll put this bomber here, and we'll say we want this bomber to kind of stay put. So we'll take a look at our merge, and we will connect the bomber. Well, what just happened? Our bomber moved to the origin, but I want both bombers to appear. That is because they both take up the exact same namespace. So all of the attributes from this bomber, since it's on our right input, are overriding the attributes of the bomber on the left. And that is because they have the exact same namespace. And we are creating a layering operation within USD. USD thinks that we are currently trying to update the properties of a singular asset instead of what we're really trying to do, which is to create 2 distinct assets. We're actually forming a composition arc, which is how USD merges and combines with itself, to put it simply. We're going to talk about composition arcs more in week 2, but for now, know that if we have 2 objects with the same namespace and we merge them together, they're going to try to overwrite each other, not create 2 distinct assets. If we wanted to have 2 bombers, we would need unique namespaces. And so we could copy and paste this bomber, throw it in here, and now we see we have our 2 bombers because they are unique namespaces. And they are unique because since nodes can't have the same name, this is vehicle bomber 1, where this is just vehicle bomber. So now that we have 2 bombers loaded into our scene graph path here, maybe we can just organize this a little. We can call this bomber landed, something like that. Let's go ahead and talk about these 4 symbols here in our scene graph and what they mean. The first one is pretty self-explanatory. This is if we are able to select the primitives. And so if we go in here, we can no longer select the primitives because this is off. And we can see this goes dark and there's a little bit of a red dot next to it. But once we enable that, we can go ahead and start selecting the primitives that we have in here. So nice and self-explanatory, that one. The star represents soloing a primitive. So we could just look at this bomber. We could just look at our landed bomber. If we wanted to expand this, perhaps, we could look at just the engines on this landed bomber, and we can see here there is a red circle, and this indicates that there is a viewport override. Viewport overrides only affect our viewport. If we were to try and render this out, it would not see our solo. This is just for debugging and troubleshooting. All of our viewport overrides only happen in our viewport and not in a final render to disk. So these next two are interesting symbols. They are the eyeball and this power symbol. And these are two different ways that we can turn primitives off. If we click the eyeball, it will make this primitive invisible. If we click this power symbol, it will make this primitive deactivated. And there is a difference between the two of these. And we can also see that familiar red circle next to them, letting us know that it is a viewport override. So what is the difference between these two? Well, the easier way to kind of explain it is to do it for real in a way that is not a viewport override. So we can actually clear this with a quick command. We can go to this drop down here and say clear all viewport overrides, and that'll just get us back to what this will look like if we were rendering. So let's go ahead and make this invisible and deactivate this bomber for real. So in order to do that, we need to make a prune node. So we'll go ahead, drop our prune in here. And the prune node is looking for a target primitive right in here to make invisible. So let's go ahead, drag and drop our flying bomber, and we have now made our bomber invisible. And we can see this eyeball has been turned off without the red dot next to it. And for our bomber landed, let's deactivate it. So we'll go ahead and just copy and paste this prune. And within this primitive path, we can just do an underscore and it should try to autofill. We'll select bomber landed and that will work. We can change this to deactivate. All right, so we have an invisible primitive and a deactivated primitive. What is the difference between these? With invisible primitives, their descendants still exist and are processed by USD, but they are not shown in the viewport or rendered. And when I say they're processed, I don't necessarily mean that it's loading in all of our geometry, but it is going through and cataloging what primitives we have in here. And it does this in case they're being used elsewhere in your scene, so it knows to fully load them. So there is a little bit of processing compute time when it comes to hidden primitives. On the other hand, our deactivated primitives and their children are not processed by USD or LOP nodes. You see, there is no way we can expand our deactivated bomber landed. If we look at the amount of primitive descendants, we can see there's only one here. There's just this primitive, where within this bomber, even though it's hidden, we still have 151 child primitives within this section. So this is faster to compute because Solaris is not looking through these child primitives for any information. We're telling Houdini that there is nothing in this primitive branch that is active, so don't even bother. The disadvantage to deactivating primitives is, like we saw, all the child primitives are inaccessible. So if we are trying to use a child primitive elsewhere in the scene, we won't be able to. It's not there unless we were to reactivate the parent primitive. This is especially prudent for materials. Let's just bring in a quick example right here. I have this purple material that is applied to this cube. It's a very advanced Solaris scene. If I were to make the material hidden right here, we can see we still have our purple shader. But if I were to deactivate the material, our cube can no longer find the material that's assigned to it, and it gets a generic flat gray shader. So now let's go ahead, dive back into our scene. We will delete these and let's continue talking about primitives, or more specifically, primitive properties. Like we said earlier, all primitives have a primitive type that define what kind of data that primitive contains. The actual data for each primitive type is stored in its properties. And to see its properties, you simply click on a primitive and they will populate in here. Let's go ahead and full screen this for a second. So we can currently see all of the properties for our engine's primitive. And properties are made up of two things. They're made up of attributes and relationships. Attributes will be very familiar to us if you have worked with Houdini at all. They just have a little bit of some funny naming, as all things in USD does. We have the points attribute right here. This is our P position. We have our normals, our N. We have our UV maps, which is an ST here. We can also notice that this attribute has a primvars prefix. Primvars are custom attributes that typically are used to help drive shader and renderer properties. We'll take a closer look at primvars in week 3, but UVs currently live within this primvar, this custom attribute. And we can actually see the attribute like a very poorly arranged geometry spreadsheet in Houdini. It's not nearly as nice to look at, but we can see what each of these vertices has in terms of a UV attribute. And the same for points. We can see the actual position data of our points in here. We can also see our normals. It's all right that these aren't as clear in Solaris because we are not really making geometry in LOPS. LOPS is meant for assembling, lighting, and rendering. So I'm not bothered too much by this being harder to read than the normal geometry spreadsheet that you would get in SOPs. So we have our attributes within here, and the other component of a primitive property is relationships. And so we have in this material binding here, we can actually see what material this mesh primitive is bound to. So we can see it's in vehicle, bomber, material, engines. So we know that there is a relationship between these two primitives here. And that is what relationship properties are for. It's for showing how this primitive is associated with other primitives. And relationships will always be read in this properties view. And a quick side note, there is an easier way to see what material a primitive is assigned to at a glance. In this dropdown, we have a variety of different properties that we can look at, and we can actually click this material dropdown. And now if we give ourselves a little bit of room here, we can actually see the name of the material that this is linked to. You do need to be careful though, because if there is another glass elsewhere in our scene, it could potentially be linked to that because this doesn't show the full namespace. If you ever want to know, you can dive in and see the namespace of the material here. And another relationship that I think is interesting that is worth showing is on this render scope right here, we can actually see the proxy primitive. This proxy geo right here is the proxy for the render geometry. And that is also a dropdown that we can see here, the proxy path. It's really annoying how this always snaps back, but we can see all of these have their proxy path associated right here. We'll take a look at proxy setup in close detail in week 3, don't you worry. But for now, let's go ahead and see the proxy in action in our viewport. So what we've been looking at in the viewport this whole time is our proxy geo. If we look close, it's kind of not the best, there's kind of some weird indents in here. And that is because in OpenGL view, Houdini knows to use our proxy mesh. If we wanted to see the final render mesh, we can control that in here. We can see that currently we have our proxy on, but let's change this to final render. Solaris will think for a second, and now we have our high-res geo in there. Let's go ahead and swap back because it was a little bit hard to see, but we can see that swap happening between those two here. It's especially obvious once we start to get up a little bit closer. That's just to optimize our OpenGL viewport once you start to get a large scene in there. So we can change back to preview. And once we start rendering this object, we will actually get the full res geometry. One last note that is worth talking about in our little quality switcher here. We went over final render and preview. Preview with guides is if you have hair groom guides. That's what it is. Typically, unless you have a furry creature or grass or something like that, we'll be working with preview, which is our proxy, and final render, which is our final render geometry. All right, so let's go ahead and full screen this. I will hit Control B, and we can actually see this render geometry in action. Let's go ahead and start rendering our ship. So we can go up to perspective, and this drop down will show us all of the render engines that we currently have installed. I believe these four come by default, and I also have Arnold, which we'll use in a couple shots here. Storm is a different version of an OpenGL render. But let's go ahead and switch to Karma XPU. Now, the first time that you load this up, it may be a little slow. It's going to process and convert your textures, so don't be alarmed if it takes a little bit slower for your computer to load it than me. That's just because there's texture conversions happening, and it will be faster once you load this a couple times. So we can see that we have our ship render here, and it's a little bit blocky as our computer is fully loading in the data. And now we can see that both of my GPUs have kicked in as well as a CPU. And we can see that we are rendering our ship. And it doesn't look the greatest right now. And that is because when there are no lights in your scene, Houdini adds a headlight. There is a light that is directly attached to the camera that is looking down on our ship. And that doesn't look very good. So let's look into adding an HDR into our scene. I'll go ahead and hit Control B. We'll minimize this. And let's add a dome light. We'll put that in here, connect it up, and take a look. So we can see our lighting changes pretty quickly. We have a lights primitive that this dome light is in, and we can see that being marked right here. And let's just change this to be HDR. All right, so let's kind of go through here. If you're familiar with lighting in normal Houdini SOPs, this section is probably very familiar. Let's grab an HDR texture. I went to HDRI Haven and I just grabbed this right here. I have the link at the top if you want to grab it. But I just downloaded the 4K version and put it in an HDRI assets folder. So let's go ahead and just dive into there, HDRI. And sunflowers, pure sky. All right, so we'll let that process for a second. And it's still thinking, it's converting the texture. That's kind of what the initial slowdown is. Once this finishes, it should load up pretty quickly. So we'll just wait for a second. And now we can see this has loaded. And we can also see it in our background here, which is lovely. And this is starting to look much, much better than it did earlier when we had that gross looking white constant light. And so we have this rendering and it's going pretty quickly, which is really fun. We got some good reflections and it's looking pretty nice. And we can see that my two GPUs and CPU, they're working hard. And let's actually use this as an opportunity to talk about properties a little more. I'm sure you're sick of it, but I want to show you that all the nodes that we are working with in Solaris are really just an interface for defining those USD properties. If we click on the HDR and we scroll through here, we should find this input texture file. And this is defining what file we want to use. It's a little bit hard to see now, but this is defining what texture file we want to use when we are rendering. So we can see that right in here. And we could manually go in and change this and it would update the HDR that's being used. All of these nodes are just a GUI interface to change these properties. Let's take a look at another example. We will isolate the exposure property. We can type into this filter field and it will only show us properties that match. And we can change our exposure to 1 or 2 and we can see it update in our properties window. And say we received a USD scene where we don't have this light node. Well, we could very easily change this property by just right-clicking and hitting Edit Property. Then when we select this, we're still able to control our HDR. There are other better ways to control this light in Solaris, but the point is we are able to do this little property edit adjustment on anything within our scene graph. We can do it on any property, and that is very, very powerful. Even if we set the exposure very high in the HDR right here, it's not changing because this is overriding our settings here. If we were to get rid of this and delete it, then we would get this 5 exposure. So that is something that is interesting to keep in mind as we start talking about layering and edits, which we'll be doing in our next video. So before we end, I just want to keep showing you a little bit about the render view within Houdini. We are also able to just switch to Arnold, and we are going to get a very similar looking render thanks to the magic of USD. We actually have both a Karma shader and an Arnold shader loaded into this same asset. And USD is smart enough to know which shaders go with which render engines. And it's going to take, again, a second to load at first. One, because it has to do texture conversions. You can see the texture conversions happening here. And two, because Arnold is a bit slower than Karma XPU. So we have this loading in here. You may have noticed the background got a little bit brighter. That is actually because we are seeing the OpenGL HDRI background over top of our real HDRI background. So let's go ahead and fix that. We can click D in our viewport, and let's go over to background, and let's just turn off display environment lights as background. So now we can see our actual HDR back here. It's not just our OpenGL representation. And now we have this loaded up and in Arnold. And this doesn't look quite as nice as I want it to. It's a little bit blown out here, and that is likely a color space issue. So let's open up our color correction. I just right clicked on this eye and hit that button, and we want to go into a tone mapped view. That's just going to be a little bit more aesthetically pleasing. We can see that the highlights aren't blown out. We'll talk about color space and do a nice deep dive in a later video. We're just trying to wrap our minds around the basics of USD and Solaris right now. No need for too much of a deep dive on color science and color theory. So something that I'm noticing in this render right now is our HDR texture does not look very good. It looks kind of strangely stretched, and that is because our format is set incorrectly. We want to set this to lat long. That is the type of background this is. Karma will set this correctly automatically, but Arnold does not. So that is something to keep in mind as we are looking at our ship here. So we can also see when we zoom in, this is never quite resolving fully. The render completes, there's no more percentage here, but it's still pretty blocky. How do we control the render settings in our viewport? Well, we can do that by going into the display options. So we can click our eyeball here, and this is where we get our render settings in this render tab. So we can change this to a value like maybe 5, and we are going to get a progressive render until we hit 5 samples. So we can see this is definitely going much slower now, but we're also getting a cleaner result. And we can control all of these Arnold render settings within here. And we can also control the Karma render settings. Let's go ahead and go to our Houdini GL view. It's always a good idea to do that when switching between Arnold and Karma, just because Arnold can be a little bit crashy sometimes if you switch at the wrong moment. And so in here, now we can see this has switched to our Karma XPU settings, and we can control the global samples and increase that to something like 256. We can enable denoising, and we will get that kind of splotchy cleanup that denoisers tend to bring. I personally don't really like to use denoising really in any form, just because I would rather kind of see the areas that we're having a hard time resolving than a splotchy mess. I feel like this gives me more useful detail than having something that is blurry but noise free. So I don't really use denoising too often, and that is the reason why. So we may have also noticed it looks like our background is gone. And where did our HDRI go? Well, remember, we turned off our environment light in our background. That is what Karma was displaying previously. By default, Karma does not render the HDRI. And if we want to adjust that, we can go into the Karma settings here. We'll see that there are settings for each unique renderer that you have installed in your system. And these base properties are global, so they apply to both Arnold and Karma and whatever other render engines you may have. So this may look a little bit funny to you if you're used to looking at Houdini parameters. Why is this grayed out? That is because these parameters are inactive. They are at their default values, so USD says, I'm not going to bother writing this data to the USD file. I know what the default values are for this type of primitive, so I'm not even going to bother writing it. I'm not going to take up more disk space for something that I already know. So we actually need to activate these properties. So we can go ahead and click and hold and hit set or create. And that will create this render light geometry. We can actually see the parameter name here if we hover over it. Karma light render light geo. So let's just look for render light geo. And by just typing render, we can see it appears. And if we were to set this back to do nothing, which is its default state, we can see that disappears. We are writing an additional property to our light. And when we check this and turn it on, we now have our beautiful clouds back in here. So if you were a little bit perturbed, perhaps when you saw that all of these options are turned off by default, don't be alarmed. USD is all about efficiency. And if we dive into our USD scene code again and we inspect our active layer, we can see this is true. Let's go ahead and we can just search for our render light geo. We can see that it is currently set to 1 because we have it on. If we were to turn this off and refresh, we see this set to 0. And then if we were to dive in and deactivate this and do nothing, and we refresh, we see it goes away entirely. So it does this purely as a space-saving mechanism. So now before we dive into learning more about different types of lights and different types of tools that we have in Solaris, let's go ahead and talk a little bit of theory about lighting in general, because I think it's very, very important to not only know the tools that we have, but to also understand why we have them and what we are trying to do. So thanks so much for listening, and I'll catch you in the next one. Hello there and welcome back. In this video, we are going to continue learning Solaris Basics by diving into creating geometry, modifying geometry, and then authoring materials within Solaris. So let's go ahead and jump right in. So before we learn about making our bomber in week 3 and doing more complex assets, I just want to talk about very basic geometry and shader creation. So in order to create geometry within Solaris, we need to use a SOP create node. And so if we take a look at this here and go to our OpenGL view, we can turn on our grid. We can see that there's not anything to look at. This is an empty node waiting for us to fill it with geometry. It is very similar to the object context, and if we were to make a geometry node within here. The SOP create is just an empty container ready for us to start modeling, loading file types in that aren't USD or what have you. So when we double click it, we can see that we hop into this empty network. We have some subnet inputs here, but you can pretty much just ignore these. So if we wanted to make geometry, let's really get crazy here. We can make a grid perhaps. We can make a tube out of polygons. We can make a sphere, just really fill our heart's desire when it comes to modeling. And we can connect these to a merge, create an output node so we always know what is going to be output from this SOP create. Maybe move these around a little bit just so we can see them. All right, excellent. So we have done a beautiful job modeling here. So let's see what this looks like in the stage context. So now we have loaded in our geometry. And if we take a look at the primitives we've created, we are creating a base container primitive called SOP create 1, the name of this node. We can just call this like my geo, and that will update. And then within my geo primitive, we are making a mesh primitive, and that contains all 3 of our meshes right here. Let's go ahead and see our beautiful geometry with all of its lighting. All right, excellent. So we created 3 objects, but we're only getting 1 mesh primitive under here. What if we wanted to split this up? What if we wanted the ability to turn our sphere off in our scene graph tree right here? Well, we can control that within our SOP create. When the SOP create loads in Geo, it is looking for a name attribute. If a piece of geometry has a unique name attribute, it will be split into a separate primitive. So let's go ahead and check that out. We'll put it to the test here. We will create a name node, and we're going to name this my cool grid. And then our tube, naturally, we're going to copy and paste this, and this is going to be my cool tube. And then you guessed it, we are going to go to our sphere, my cool sphere. That one gets a capital. So when we go back to our stage context, we can now see we have these in their own individual primitives. So we can control them, turn them off and on, assign individual materials to these primitives. It's very, very handy. There is also another way where we can be even more specific with where each of these is going, because the SOP create is not only looking for a name attribute, it also accepts a path attribute. Now, the difference is that a path attribute is going to define the entire namespace of our primitive, not just the name of our individual mesh primitives. It's going to both name this mesh component and decide where in our scene graph tree it lives. Let's go ahead and test that really quick. So if we go back into our SOP create, we can create a primitive wrangle. And let's make a path attribute for our grid. We are going to make a string attribute named path, and that will be equal to slash my own path slash this is my grid. He is lonely. And then we will end this with a semicolon that is running over our primitives. So now, when we go back up to our stage context, we can see within my geo, we're still reading the name attribute, and we have our cool sphere and our cool tube. But we also have this my own path. And look at this lonely grid. He is in his own transform primitive. So we could just control him on his own, or we could control both the tube and the sphere at the same time, since they're in the same myGeo primitive. I will typically just use the name attribute because I like to be able to control the placement higher up without diving in, but we can use the path attribute. And if we have this path attribute, it is going to override this name attribute. We can see our grid is not called my cool grid. It is called this is my grid. He is lonely, as we can see right here. So let's just get rid of that. So we have created geometry. So not only can we load in your typical polygon geo through our SOP create, but we can also load points in, we can load curves in. So let's take a look at that really quick. Let's go ahead and just scatter some points on our grid, just because, I think that would be a good example. We can scatter some points right here. Let's also do a little point jitter, just so we can get them to move around some. And we can copy and paste our name attribute, and we'll just call these scattered points. The name doesn't really matter, it's just so that we can see it. Now when we go back up into our rendered view, we can see that we have all of these points being rendered as spheres. And since they are points, you can't actually put a name primitive attribute on it. So if we go back in here, let's change this back to point. And we can go back into our stage, and now we have our name scattered points. And we can control how big these individual points are, like we could in normal Houdini with the p-scale attribute. So let's go ahead and make an attribute adjust float, and we can just make some random p-scale attributes really quick. We'll go random, min we'll do 0.1, max we'll do 1. Now, if we go up into our stage, and when this reloads, we can see we have some very big points. Maybe one was a little bit large for this example. Maybe we can do like 0.2 and 0.01. And now when this reloads, we can see that we are determining the scale of the points through that attribute. And we can also make a curve very quickly. Let's just go ahead and draw a curve. This is going to be really something. So we're just going to do that. Great. And we can give this a name attribute because we like to stay nice and organized. And this we will call our curvy curve. Excellent. Go in here and let's go ahead and see our curve loaded. And so we can see that our curve is also in here. It's getting a little bit tricky to see. Maybe we can turn off all of our other items here except for our curve. And it looks like we ran into the same issue here as far as naming it. Curve 0 is the default name for our curve. And so this one just needs to be changed back into primitive since we have primitives here. And there we go. There's our curvy curve. And this can be controlled with the width attribute, with the p-scale attribute. We can use our SOP create to load in all of these wonderful different kinds of geometry onto our stage right here. So SOP create is really your one-stop shop for loading in geo just kind of quickly at a whim. There are better ways to make assets than just loading them into this SOP create, but it's a quick way to get things in your scene if you would like to do it that way. So now that we know how to load geometry into our Solaris viewport, what if we wanted to edit our geo? What if we wanted to, say, turn some of these panels off on our bomber here? We don't really have the control within our split out to do that. Let me just turn this grid off while we're looking at this. You know, we could turn all of the panels off, but what if we just want to turn maybe a couple of them? How would we go about doing that? Well, what we can do is we can use a SOP modify node. And if we put this right in here, this is going to ask us for a primitive to modify. So let's go ahead and grab our render panels right here, since that's what we want to adjust. And we want to make sure we are bringing in the render purpose. By default, it is going to load in the proxy, and that is not what we want. We want the geometry that we're actually using to render. So let's just select the render geo, and we can dive right in. And so we can see we now have our panels all loaded in here, and they're ready to modify. And so from here, we can select our geometry, but we can see by our spreadsheet, we only have one piece. If we middle mouse click, we can see that really we just have one packed USD file. So we need to unpack it to real geometry. Now there's a couple ways we could do that. We could do unpack USD to polygons, and this will unpack all of our geo and allow us to select it. Or if we don't want to make this node, we also have an option at the top to check unpack USD primitives to polygons, and it will do that kind of at the top level. You know, you can really do one or the other. It doesn't really matter. It's just your preference. So let's go ahead and select some 3D connected geometry, and we'll just remove a good chunk of paneling on our object here. And we will hit delete to make a blast node. Let's go ahead and make sure this is above the out. And we can see we have removed a lot of the paneling on our ship. And now when we go back into Solaris land, we can see we have removed all of that paneling, and it has placed our updated panels right back in here. And our render geometry now has all of that removed. And if we look inside of our SOP modify, we will see some familiar attributes. We just talked about how we use the path attribute and the name attribute to determine where in our scene graph the geometry will go. There are some extra attributes here for our materials and other things to kind of help define more relationships and whatnot. But this really behaves very similarly to a SOP create node. And we could take this even further. Maybe we actually want to not only remove geometry, maybe we want to edit it and maybe add some new polygons. What if we wanted to adjust our glass so it was cracked? Let's go ahead and make a new SOP modify node. And we will grab the render purpose. And let's go ahead and grab our glass within here. We will unpack the USD primitives to polygons so we can edit them. And then let's dive right in. All right, so we have our glass within here, and we can just do a really quick RBD material fracture just for the sake of speed, we'll put this in here. And let's do a glass, and we will fracture per piece. And we will need to have a unique piece attribute. And right now our piece attribute is not unique. It is just the name that is coming in by default. And if we just make a null here so we can select, we can see everything has the exact same name. So our shader is going to be a little funky. Let's just make a connectivity so that every single unique 3D connected geometry has its own attribute, and that is under the class attribute. And let's just change this from name to class. And now each of our windows has its own unique broken shader. And from here, we will turn on 3D connected geometry again. And let's just select some pieces for us to get rid of. Something like that, something like that. I might have gotten rid of some here, and then we'll just hit delete. All right, now we've gotten rid of a good chunk of glass. And when we go back up, we have our brand new geometry. And we can see our glass is broken. A little bit sketchily, but we could be much more careful with this broken glass if we wanted to. But it's just another thing we are able to modify. We are actually creating polygons on the edge of our glass right here. Those are brand new. Those didn't exist before, and it's inheriting the glass shader. So really, really cool stuff. We can not only delete, but we can also add to it, and it will try to retain all of the attributes to make sure it lands within the correct location in our scene graph tree. Something that we have accidentally done, if we expand our attributes on our render glass, we will likely see a primvar class. It is recording that data that we made to know what pieces are individual and unique. And so maybe the cleanest thing to do would be right before this out, we make an attribute delete, and we just clean up any attribute that we don't need, just so we're not writing any unnecessary data. So within the point, we will delete our class, and then all of these other attributes are being used by USD, so we need to keep them. And when we go back up, we should see our class attribute has disappeared, and we're just trying to keep this as lightweight as possible. And so another thing I do want to chat about is, what does our USD code actually look like when we are using these SOP modifies? I want to just turn off the panels one just so we can focus on the glass specifically. So if we were to right click and do lop actions and inspect active layer, we can see that we are now defining new geometry for our mesh glass. We are overriding the geometry that previously existed within this. So if someone else was using our asset right here, it would not be changed at all, but maybe there's a single shot where we need to modify the glass for. We are storing all of that geometry data just within this USD scene. It's not being saved back to the root in any way. And then all the way at the bottom, we can see our light controls again there. So we're actually replacing the mesh primitive data wholesale by using our SOP modify. It's not just that nice single line anymore where it's just like, all right, we're going to load this in, and that's our geometry. So it's something that's good to keep in mind. So that is what I wanted to cover in terms of just quick geometry creation and modification. So let's turn and start talking about materials. We can just use our My Geo Scene. Let's just simplify this a little. I want to get rid of the curve and the points just because I don't think that we need them. Let's start talking about creating and assigning materials within Solaris. So the primary way to create a material is within a node called Material Library. And we'll place this inline here. And our material library acts like our matte context. And if we were to dive inside, we would be able to make all of the shaders that we know and love. We could make an Arnold material builder. We could make a Karma material builder. And once these are created and have this output flag turned on, if we go back into our stage context, we can see we have this materials primitive that is just a scope that is housing our materials. We are automatically bringing in whatever has this output flag turned on. You can see the Arnold material builder disappearing as I turn it off and on, and we are able to load materials into our scene this way. And so maybe we want to organize this a little bit more with this my geo. Let's go ahead and do my geo slash geo. We can house all of our geometry within here, and our material library we can put in my geo slash materials. So now our materials have locked into this little asset container that we have right there, and we are loading them into this location. We could put these in unique locations if we wanted to. If we hit autofill materials, we can see that we can now control these individually. When I hit enter, this is now in an individually scope folder. And so let's go ahead and undo that and clear the materials that we made, and we can reset up the original settings. So we can turn on only include VOPs with the material flag set and use a wildcard in material VOP, and that will just load in all of our materials. So we have our materials created. Let's go ahead and just create something in our Karma material builder. This is a standard PBR shader. There's nothing too crazy that's in here. And we can make this maybe more of like a cyan color. We have inputs for our textures that we want within here. We have a displacement input with scale. We have material properties. When we start talking about Karma, we'll dive more into this, but we are just making very basic materials for right now. So we will get rid of our Arnold material builder. We can call this blue, and then we can make another one called metal. And within here, let's go ahead and turn our color back to 0.1. We'll turn our metalness up so it is metal, and we'll turn our roughness all the way down. So what we could do with the material library node is actually assign our materials to our geometry. If I check this assign to geometry button right here, I can drag and drop the primitive path, and we will assign this shader. But right now, this is kind of a wild card. It's trying to grab all the shaders, so it is grabbing our most recent one and assigning it. We probably want that to be a little bit more specific. So we could instead select from here, metal, do something. Maybe we want it to be blue instead. So now the blue shader will be assigned. And from here, we could then grab our metal shader. And let's assign this to our tube. I will select our tube and hit enter, and now our tube has our metal shader. And if we were to turn on material info in our scene graph tree, we can see that that is assigned right there. Let's actually make a third material within here. Let's make a yellow material. Yellow, and we will make this yellow. Assuming I can guess the right color combo, perfect. Alrighty, and we need to make sure we're loading this in because we got rid of our wild card. So we can just grab our yellow material, and we can see this is in the correct spot. We're not automatically loading in anymore because we got rid of our wild card. So there is another node that is a little bit more powerful than just the material library when it comes to assigning materials, and that is the assign material node, very aptly named. So the assign material node will look very similar at the outset to assigning materials using the material library. It is looking for a primitive to assign a material to and a material path. So we are very familiar with this. We can go ahead and grab our cool grid, and then we can grab our yellow material and assign it. All right, wonderful. So that worked. So why is this any better than our material library? Well, let's look at one of the reasons. So let's say instead of assigning this yellow material just to the grid, we wanted to assign it to the myGeo parent primitive. So let's go ahead, drag and drop that right here. And we can see that we have successfully assigned the yellow material to this node, but we still have our metal and our blue. Why is this? Well, Our metal and blue materials, if we look right here, these mesh primitives have direct material assignments specifically for these mesh primitives, where when we are using our assign material, we are placing it on the parent primitive, and anything that doesn't currently have an explicitly assigned material inherits this parent primitive. And so since these were specifically assigned, they are not updated. These have a stronger opinion than the parent primitive. Another way of saying this is that a local prim opinion is by default stronger than an inherited opinion. But the assigned material allows us to change the strength of this opinion. That is what this strength parameter is for. We can change this to stronger than descendants. And now we are overriding those materials. These inherited descendants are stronger than those very specific ones that we set earlier. So that is one reason you might want to use the assigned material node, because we can set opinion strength. You can also see that we can assign materials to full render, the proxy render. We can be a little bit more specific with the material binding. And we can also use Vex to assign materials in a little bit more of a procedural way. We'll dive into this more in a later video, but it is another reason you might want to use an assign material node. So let's go ahead and get rid of this and take a look at another way that we can assign materials, which is by using the material linker. So if we drag this guy in here, this GUI will populate with our current geometry and our current materials. And this is just a little bit more of a graphical way for us to assign materials. We can drag and drop and assign our blue material to our grid. And we can see when we have our blue material selected, we can see that the rule is we are assigning this blue material to myCoolGrid. If we apply it to the tube, we can see we are applying it to myCoolTube, and we can undo these if we don't want these rules to apply anymore. And we are also able to see all of the functions that we are doing with this switch node. We can see that we are making two links within this file, and we are linking the blue to the cool grid, we're linking the blue to the cool tube, and so it's just a little bit more of a graphical way for us to make those changes. And we can just clear them if we don't want to use them anymore. And another way we're able to work this is we can drag a material into our rules, and then we can shift click and grab all three of these and add it to our bindings list. We can see this all gets blue. Well, we could double click on this and we could see the actual primitive pattern that we are currently using. But this could be a little bit of a pain to dig through and try to delete the exact one that we don't want to be included. And so what if instead we could just drag and drop and say, I don't know where this is in here, but just exclude it from this ruling. So now our tube is no longer blue because it is excluded from this list right here. Something that we are able to do within this context is use primitive patterns. And so we can use a wildcard here. And then when we hit apply, this will apply to the grid despite not having the grid specifically listed in here. We're grabbing everything within the myGeo context. That's not something that is necessarily unique to the material linker node. If we go into the material library and we just connect it and bypass our material linker, we can see that we can assign our metal to everything within our geo primitive, just like this. So let's go ahead and undo that asterisk just so we're kind of back to our default state. And we will go back into the material linker and let's just clear all of these assignments. So there is one other really handy feature of the material linker, and that is this catalog tab. And this catalog tab comes with a bunch of predefined material X materials, and we can import these into our scene very, very easily. We can grab this glass and put it in our material folder, and we can see it populated right here. And this is green, signifying that using this node, we are inserting it into our scene graph. And so we can then drag and drop on our sphere, And we have applied this glass onto our cool sphere. And we can do that with any number of these materials. We can grab this really bright green. If we just drag and drop over here, it's going to put it in a materials folder on our root. And it's good to stay organized, but you can't really move this once you place it, which I think is really annoying. But we can just kind of delete it right here. We have our files and internal references, which is where our new materials come from, and then material assignments at the bottom. So we can just get rid of it and then bring it back into the right space. So just make sure we're placing it carefully when you use these materials. Now, these ones that come by default, they're okay. If you look at them pretty close, like let's take a look at this granite. Let's assign our granite to our grid. And when we go in here, we can see that they're not really like the best materials. It'd probably be best to see these on a shader ball, which we actually have test geometry for right here. Let's go ahead and just plug our HDR into this shader ball that comes by default with Houdini, just because it's nice to kind of see shaders within this context and not on this weird geometry that we made. So let's go ahead, make a material linker. And then within here, we have our shader ball materials. We can just drag and drop in here. So we can grab our granite again, load it in, and we can assign this to our preview surface by dragging and dropping. And we have our granite material. Now this is all right. It's not, the best, but we do have the opportunity to use a really nice library from AMD. They have their own AMD Material X library, and these I think are much more useful than the default ones we see here. So if you hit Open AMD Material X library, it's going to ask you where you want to download these materials to. So being the nice organized people we are, I'm going to just make a mat folder. And then we can call this AMD Mat X, and we'll do _publish because that's where I like keeping all of my materials, and we will pick right here. So now that is going to open up the AMD material library. And if we give ourselves a little bit of room here, we can see we have some much higher quality materials to start working with. And these are great starter materials. They're not necessarily hero, but like some of these marble materials look really nice. If we drag and drop over, it's going to freeze for a second as it pauses to download, but then we can drag and drop on our preview surface and we can see what this blue marble looks like. So it's pretty cool. There's a lot of nice, just small patterns within here that we can grab. There's a lot of different things in here. Like what's kind of a weird one. We have this patchwork rug. We have this marble here. Lots of good marble shaders. I do think some of the Megascan stuff that we'll be using later is better, but this is just so easy to grab. We can just download it, assign it, and we have it loaded within here. And we have some dirty concrete. Maybe that will be useful for us. I don't believe any of these that I've downloaded so far, at least, come with displacement. And so I think we're always kind of going to miss some level of detail because of that. But you can see we have this nice little like dirty concrete on here. And honestly, this looks pretty decent. So what if we had one of these on here like this tile and we wanted to affect the UVs? What if we wanted this to repeat more than we are currently seeing? Well, that is where a new node is going to come into play. We can right click on these materials and say Edit Material Network. And if we kind of give ourselves some room, we have made a Edit Material node with this material selected. Now, this node is something that you can just make on your own. It's not unique to the material linker, the Edit Material Network. And what you do is you specify a material you want to edit, and then you hit load. And if we dive inside, we can see that it is trying to recreate the original material network used to author that material. Now, these AMD Material X materials are a little bit unruly to look at. It's definitely easier looking at materials you've created yourself, but we can just dive into where all of our images are. And then from within here, we just have this multiplier that we can apply to the UVs. If I turn this on, I can change this to like 8. And we can see we are now tiling this material and changing how often it repeats. So it's a pretty handy node. We'll definitely make use of it later in a less confusing context, but just know you can dive in very easily to any of these AMD materials and just start tweaking how much they repeat just by going in and adjusting this UV. And you can kind of dive into the rest of the shader if you want. And we can control much more than just the UVs through this node. We can really affect any facet of the shader. If we make a multiply, we need to make sure we're doing a material X multiply. We can tint this to a different color. You know, we can tint it a little bit more there, something like this. We could make a color correct beforehand, potentially make sure it's a material X color correct and not the Arnold variant. We could desat this so our color is overriding a little bit more. You know, if we go up a level and then up another level, we can control like how much diffuse contribution there is to this. There's really a lot that you can tweak. It's trying to rebuild the entire material network. And so this is a very fun node to use. Don't be intimidated by how crazy this one looked. These AMD Material X materials are just kind of crazy. And so that wraps up our basic geometry and materials in Solaris. We'll definitely dive much deeper into geometry and materials later, but for now, let's go ahead and move on to lighting. Before we dive into lighting nodes, I want to first talk about a little bit of theory. I want us to understand the reason why we're using lighting nodes and why we're hitting the buttons we're pressing, because to me, that is the most important part. So our next video is going to be the first section of our cinematic lighting principles. Thanks so much for listening, and I'll catch you in the next one. Hello there and welcome back. In this video, we're going to go ahead and start talking about some lighting theory and dive into what I call cinematic lighting principles. So let's go ahead and get started. So we can't really talk about cinematic lighting principles without talking about cinematography. And as you probably know, cinematography is how you light and frame the film you are creating. But to me, really, cinematography is ultimately about telling stories visually. Cinematography informs the viewer of what sort of mood or emotion they should be experiencing through the scene. It helps give context to the story for the action that is taking place on screen. Just through the way that a film is shot, you can tell if it's supposed to be suspenseful, if it's optimistic and hopeful, if it's in a very dark and scary place, if we're unsure of the surroundings that we're in. That is all conveyed visually through the cinematography. And it's just about visual storytelling. I'm going to keep saying that in this video over and over because of how important that is. And knowing the story behind your shot or sequence is so important because it is going to help inform your creative decisions. The story drives the emotion and the mood that we need to be conveying through the scene. Trying to light a scene without the story or any other context is like trying to write a chapter in a biography about someone you don't know. Sure, you may get a couple of details right and some bits may be nice to read, but it's not going to be accurate and it's not going to fit into the larger piece that you're trying to assemble. So it's really important to have story-driven visuals. And if you're working on a movie, that's great. There is always a story. If you're working on a personal project, I think you should always make up a story that informs what you're trying to do. Don't just try to make a good looking image. Try to make an image that tells a story because it's just going to help all of the decisions you need to make down the road. And when we are talking about cinematography, generally discussions will focus on one of two aspects. There is the lighting component to cinematography and then the compositional component, which takes up the framing, the way that your set is laid out, trying to create depth. This video is going to focus mainly on the lighting aspect, and we will focus on the compositional aspect in a later video. And so let's go ahead and take a look at some examples to show visual storytelling. I have a lot picked out for us here, so let's go ahead and start to go through these examples. So in our first slide here, we have the very first time we see Hogwarts in Harry Potter and the Sorcerer's Stone. This is the first time the audience has seen it, the first time the students who are coming up to it in a boat have seen the school, and it feels very, very surreal and almost painterly with the way this lighting is. It's not necessarily super intimidating, but there is a bit of darkness inside of it. But honestly, if I had to describe this with a word, it would feel magical. And that is really what the audience is supposed to be feeling here. So I think it's a really good example of using lighting to really emphasize the mood and the theme of what the shot is trying to convey. They're coming onto a very magical place. In Dune, this is an image when the bad guys are sneaking up on our heroes, but they actually are being ambushed themselves. And this is foreshadowed in a way by the lighting that we see on the frame here. We can see that they're coming in and out of all of these shadows. Some characters are in shadow, some are in the light, and the shadow represents them thinking that they are sneaking up on the enemy, but really they are being ambushed themselves. So the lighting does a nice job of sort of visually giving the viewer a hint that they are not as stealthy and sneaky as they think, and they're actually much more exposed. In Blade Runner 2049, this environment feels very worn down. The colors and the dust make it feel very unsettling, like you shouldn't go in, which is a major story point. No one has been in this bombed out version of Vegas in quite some time, and the lighting and all of this atmosphere really help reinforce that. The way that the haze is obscuring the building along with the overcast lighting really makes it feel like this was a bombed out area that is likely still contaminated, and that's really what we're trying to convey with this shot. This is another still from Blade Runner 2049, which I think is another nice little foreshadowing element of lighting. There's a little pool of light coming from the screen right here in this very complex environment as our hero is looking for an answer in a very complex mystery. And there is a little bit of an answer in here, and the light helps represent that. And this next still is from The Matrix. Neo is nicely silhouetted by this waterfall, and Neo is currently in the dark, as we can see by his silhouette, and he's searching for a abstract answer, something he's very unsure of, which is represented by the nicely backlit waterfall. In Prometheus, as we're flying down, this is a very beautiful landscape, but also haunting in a way, which represents the journey the characters are going on as they descend into this planet. And some of these are more heavy-handed than others. You know, I think these Blade Runner examples here, I think this is a bit more of a subtle lighting choice, where in Lord of the Rings, this is much more on the nose, where the good is coming in to defeat the evil. We have all of these god rays coming in from this side of screen, and the evil is here in the dark. And it's a very big tone shift from what we saw earlier, where everything was very dark and rainy and you couldn't really see what's going on. And it helps tell the story visually that way in a really, really nice way. And another one from Lord of the Rings, very heavy-handed again. We can just tell it's very dark, moody, mysterious in Mordor, where in Minas Tirith, very light daylight. You know, the way that this grass is kind of lit, it almost just feels like you're looking at your backyard on a bright, sunny day. And this image that we have right here is from Days of Heaven. And what typically would be lit as an idyllic, you know, like maybe Midwest landscape is actually seen almost in a way like we see Blade Runner 2049. Something is very wrong. The strong contrast in our character. There are no bright colors being used. You know, this looks like it was filmed sometime around sunset, which we normally expect to be beautiful, but because of the way that this shot is composed, because of the contrast, because of the haze that is in front of our house right here, it doesn't feel as magical and idyllic as you would typically expect. And so these examples, I hope, help show that lighting is critical to the audience's emotional response to a scene. It helps contextualize what they're looking at, and how they should be feeling, or maybe what they're feeling in their gut subconsciously. And shots with very similar content communicate entirely different emotions based solely on the lighting. So I have a couple examples of that here. We have the same location in Lord of the Rings. This is Rivendell, and very different moods between these two shots. This is early in the trilogy when we are very hopeful as we're taking off on this quest, and we've never seen this elven city before, and it's very beautifully lit, where here it's very overcast and the colors are very muted, and we can see there's not a lot of signs of life in this once beautiful place. It's the exact same set, just with different lighting, and you have a very different emotional reaction by looking at these two different lighting setups. And these two shots from Harry Potter, I believe this is from the first one where we are taking the train to Hogwarts, and this is from the third one where we are going to Hogwarts, but Dementors are about to attack the train. The content between these two shots is very, very similar, but the feeling we get by looking at these two train establishers is very, very different. We can tell that odds are pretty high that something bad is going to happen here compared to this, which feels very normal. And there's nothing kind of making us question if something really bad is about to happen. And so at this point, we have talked about our primary goal enough. Our primary goal is to communicate the emotion, mood, and story of the scene. So let's go ahead and move on to our secondary goal. Our secondary goal is to direct the viewer's eye through contrast. We want our viewer to know exactly what the subject is the second we cut to the shot. We want the subject to typically be easily separated from the background so it's not confusing as to what the audience should be looking at. And through lighting, this is mainly done through contrast. The human eye is drawn to the contrast of values of our luminance. Our eye is also very drawn to contrasting colors, which are very sharply opposed to one another. So let's go ahead and start diving into examples of directing the viewer's eye through our value or luminance contrast. So in this first image, it's very, very obvious. We have a silhouette of a character who is hitchhiking. It's very clear that he is looking for one of these cars to pick him up, and our eye is immediately drawn here because of how abruptly we go from dark to light. And we have a very nice secondary contrast here as well, where we have a very bright headlight and then a darker car. And our eye, when looking at this, sees our character and then moves over here because of those differences in luminance in our contrast. And Exorcist, a very famous shot, very, very obvious where we should be looking in our scene. Could you imagine if they didn't turn this one light on and he would be completely lost within? We would have no idea what was happening in the shot. It would all be dark like this right here. This creates very good focus of the audience's attention, a very clean silhouette that our eye is drawn to. The eye is drawn to human forms. So when you can pick a human form out as cleanly as this, in addition to the contrast, our eyes are going to go right there every single time. And more contrast both in value and color. Our eyes immediately drawn here, this very bright light next to this very dark house that is not quite silhouetted, but creates very nice contrast that brings our eye immediately to the porch. And when it comes to character lighting, again, very, very nice contrast in the front where we have this very bright hit, as well as the back where we have this very dark shading here contrasted against the fog. So this one I think looks really, really nice. Very easy to pick our character out. And starting to move a little bit more environmentally, this is another shot from the creator. We have a couple nice contrast zones in this. So the subject is clearly this large crater, which compositionally our eye is drawn to thanks to the shape, but this also uses a good bit of contrast to draw our eye to the first subject, which is the crater, and also the secondary subject, which are these buildings. If we look right around here, we have a very sharp fall off from a very bright highlight into this pretty dark crater. So that helps draw our eye this way. And this very subtle gradation back here, this atmosphere, allows us to pick these buildings out much more easily and communicate the second part of the story. We have this huge bombed out area, and it also took place within a massive city, which is very easy to see thanks to the fog and haze which we have in our background. I really, really like this shot. It does a lot of things compositionally very nicely to draw your eyes to the crater as well. And like I said, we'll talk about composition in a later video in this course. Another environmental example, when we are outdoors, a lot of the times clouds will be used to obscure light except for where the sun needs to peek through to guide the viewer's eye. So if we look closely at this shot, we can see that we have a ship that is getting picked up. If this was in motion, it'd be easier to pick out, but it is nicely contrasted against this dark mountain back here. And we also have some patches here that are kind of left over from the light that's hitting the ship. And it's very clear that we are heading to home base thanks to these nice patches of light. And another very similar example here. We have another break in the clouds that is illuminating this large dust storm right here, but it is also very brightly picking up the trail that is being left by the little escape vehicle right here. And it's helping guide our eye towards this secondary ship. It's not really illuminated over there, but we are drawn to it because that is where our smaller ship is moving. But you can see there's not nearly as much contrast on this ship on the right. It's not picked out as much because we're supposed to be looking here in the dust storm as well as this trail following our smaller escape vehicle in this section of the frame. And this one uses natural formations. It's very clear that we are illuminating. Our eye follows this shaft of light into this temple, this ancient city. I forget exactly what it is in Prometheus, but I do know this is one of the places that they end up going. And even in shots where there's not a lot of inherent contrast in the lighting itself, this is very soft and overcast, we still have a great amount of contrast comparing our characters to the background. We can very, very easily pick all of these characters out thanks to how brightly exposed the background is. And if this background was more in this tone right here, they would probably be backlit so we can read their form. Even this character who's the furthest back, we can pick him out very nicely because he is much, much contrastier than this area that is back here. And it allows us to pick out these ropes and nice details of the ship as well. So even though our shot itself may not have contrasty lighting on, say, the characters, that doesn't mean we can't have contrast. We still need something to separate our characters from the background, and using haze like this and in earlier examples on the creator on this shot, I think is a nice way to use different values to really draw attention and make it very clear what your subject is. Let's go ahead and talk about color and how it can draw the viewer's eye and help add subject separation. This is from Blade Runner 2049. Again, these pops of contrasting colors immediately draw your eye to this character, which we then sort of follow and see our character illuminated here. Much less contrast, but still enough that we pick him out. This contrast dominates, and then we look to our character here. John Wick has very contrasting colors that draw us to his face, the contrast right here as well. It really helps us pick him out against this background. We have an interesting alternating color scheme in our lighting here. Not only does this use luminance, but we can see we have the yellow illumination on this door frame here, where on this character's front side, we have a very blue lighting effect, which helps him stand out. And then on the background, we have more of a blue on this side, and having this very warm light rim him makes him stand out even more. And let's get rid of these. That's not as helpful when I zoom out. In these characters, again, contrasting red against the background helps us pick them out. When they're over this red, it actually helps them blend in a little bit, but it's mostly used to pick them out. And another interesting facet of colors is that it can help us be more spatially aware. This character just came from a room that was very orange, lit by candlelight, and she is now hiding from her potential captors, and she's hiding in a closet. And this helps us spatially orient ourselves. We know that she's hidden away somewhere out of view in the main room, and the luminance and color helps draw our eye right to her eye. And these are more of the same, where we have just different examples of contrasting colors. I think this one is very interesting, where the only not bluish green color is her face, which really kind of helps us pick out that silhouette compared to everything else in the shot, which I think kind of just blends together, because the story point in the shot is they are leaving their water planet to go to Dune. In this example, we have very decontrasted colors except for the fire. Here, very, very saturated red smoke coming down, which helps us pick them out against this cloud. If this was, dark gray smoke, we wouldn't really be able to see that as clearly. And we have nice blue being contrasted against the warm red tones on the outside. So these are all just different examples of how we can help separate our subject from the background and draw in our viewer's eye. Now, I'm going to put a little bit of an asterisk on our secondary goal right here. While it is important to direct the viewer's eye and separate our subject, we should not do this if it's going to interfere with the story point, if it's interfering with our primary goal. Potentially, a story point could be a character is in the shadows and the audience isn't really supposed to notice them until they move. We don't want to pick them out too easily beforehand, and that needs to be done to taste. Should the audience be seeing what is the actual subject or secondary subject of the current shot? Let's take a look at two examples. This first one I think is brilliant. It's used in Hereditary, and the first time I saw this, I jumped quite a bit. But the primary subject is very obviously illuminated here along the edge. But as you start to look closer and closer at this shot, you realize that there is this possessed demon ghost. I actually haven't seen the movie, but I have seen the scene, hiding in the upper corner of the frame. And this is a secondary subject, but the audience isn't supposed to know about it unless you are eagle-eyed and looking around the frame, because it's not being picked out. And it's a very, very unsettling cinematic choice that they made to not illuminate her at all. And it works very well because of just how hidden she is back here. And I think another really good example is in The Batman, the latest one to come out, at least at the time of recording. He emerges from the shadows. He's very hidden, and the story point is that he could be lurking anywhere to come and beat up some thugs. We don't see him until he steps out into the light that is illuminating the thugs. I have the actual clip right here that we can just full frame, and we'll see exactly how clearly this comes through. It's a lot of pixels, but we can't really see anything until he steps into that very subtle light. And even then, Batman is still very, very dark. He's not well illuminated. And that is done in service of the story, which is what our lighting should always do first and foremost. So I think these are really good examples of letting the secondary goal go for the sake of the story. And so it's always important to keep the story in mind. So let's go ahead and move on to our third and final goal. This one is a doozy. And it's so much of a doozy, I want to save it for its own separate video. So thank you so much for watching, and I'll catch you in the next one. Hello there and welcome back. In this video, we are going to continue talking about our cinematic lighting principles. So let's get right back into it. Our third goal when it comes to cinematic lighting is to create an aesthetically pleasing image. What an incredibly broad and subjective statement that is. Aesthetically pleasing image. What exactly goes into that cinematic look that makes it aesthetically pleasing? Well, we are going to break it down into three basic components that I think are just paramount. They're so important to creating that cinematic lighting look. The first is modeling our scene or subject with light and shadow. We want to try and show off the three-dimensional nature of what we have in front of our lens. We want to place shadows in a way that makes our scene not feel flat. And the next thing we want to do is shape the actual quality of our light itself. Is it very harsh and direct? Is it very soft? How do we combine these together to create something that really helps emphasize the modeling of our scene? And the third component is we need to try and create a pleasing contrast and color palette, which is a bit of another broad subjective statement. So let's dive in and take a look at examples of what I mean by each of these three components of making an aesthetically pleasing image. So first, we're going to dive into modeling our scene with light and shadow. What exactly do I mean by that? So I have some images here. So this is an example of lighting that does not model our subject. The lighting is very, very flat, and it doesn't introduce a lot of feelings of three dimensions. We know this is a three-dimensional person, but it's not shaped in any way that kind of helps give us that extra information. Let's compare this to an image which does show off much better modeling. If we take a look, we can see right here that we have nice gradients as we fall into shadow. We can really start to feel the shape of this man's face thanks to the shadowing that we have in here. And as we start to move the light at more of a 45-degree angle, the area where we're feeling our gradient is larger and it's much more effective across the scene. We can see we have a little bit of a peak of light right here, which is nice. There's a little bit of light around his eye, which kind of helps break it up from the shadow. There's lots of nice subtle gradients throughout the face on this middle image. And on the right image, we have nice gradients on this side, kind of shaping around here. But once we get to the shadow side in this area, there are significantly less. We have some in his eye socket here, but there's not nearly as much in that area. And so I feel like this middle image, personally, I think it feels the most cinematic because it's showing off the most modeling of our character's face. It's also much more dramatic than this character on our left. So part of this is also very much story driven. But I think all three of these feel significantly more cinematic than this front lit lighting. And so this is what I mean when we are trying to model our image. So let's go ahead and take a look at some more examples here. So when we're modeling a subject's face, for instance, or a scene, something that we tend to do when we're lighting is have the camera on the shadow side of the light. On the left side of our image here, this light is on the same plane as our camera, where this one is shooting in the opposite direction. And when we shoot in the opposite direction on the shadow side, we get a much nicer gradation of light. We're able to see it much more clearly because it's directly exposed to us. The gradient is still technically there when we shoot with the camera on the non-shadow side, but it's largely hidden by the contours of her face. It doesn't cover nearly as large of a screen real estate, and so we get a lot more sort of flat areas around here. And that is something that when we're trying to make a cinematic image, we're trying to really enhance the natural shapes of our subject. And I did a little bit of a top-down view so we can have a more clear example of what I mean when I say shadow side and camera side. And let's go ahead and draw a line from our subject's nose right here. So in our bottom example is our shadow side, and we can see that the light is shining opposite the sort of 180-degree line of our subject right here. So we are actually facing the side that is receiving the shadows. That is why we are saying shadow side camera. And in our top image, this is when the light is on the camera side. And so as we point this direction, we're not catching all of those nice cinematic shadows. We're seeing more of this sort of flat, broadly exposed face, just like this example right here. And This still shows off nice shaping on the right side of frame, and maybe if we did some more adjustments over here, it would feel a little bit more cinematic, but it does feel a little bit flat currently on that side of her face. And while we're in here, I did want to kind of mention a very, very popular lighting technique that is used in films everywhere, and that is the Rembrandt lighting. This is a painting by Rembrandt for which this lighting technique is named for. And it is very, very famous for having this little triangle of light on the cheek. It shows off a lot of shaping, a lot of dimension. And once you start looking for it, you will see it everywhere. We can see that we have that nice Rembrandt triangle on this side of our character's face, and it just helps add another level of gradient and shaping, and it just looks so, so nice and cinematic. So you will see that Rembrandt lighting all over once you start looking for it. And so let's take another look at example of, having modeling in our scene, having a nice shape to our light that it's bringing to our subject. And so in this top image, the overhead lights are on. It's really filling out a lot of the shadows on our character. We can see we have a bit of a blue light kind of hitting the edge here around her nose and mouth, but it's pretty flat overall. And in the bottom image, once we turn it off, we start to get much nicer gradients flowing across her face. We have a little bit of that Rembrandt triangle there with very, very soft light, but we have that kind of same hit. But in addition to that, we have such a nice gradient going across her forehead, kind of going around this little triangle on her cheek. And it feels much more cinematic because of that. If we continue taking a look, let me just zoom out a little bit. We can also see that by turning off the overhead lights, we've also increased our contrast. The background is now much, much darker than our subject because it's not getting directly illuminated by the window. And we have a nice gradient in our background here as well. And we've added these lights, which are again showing more shape. We're seeing more shadowing that's happening, more gradients, which are giving us a more aesthetically pleasing image. So I think this is a really nice example that kind of shows what having modeling in your light can do when we're showing really the three-dimensional nature of our scene. And this is a reason why films don't really shoot at noon. It's because shooting at noon in direct sunlight, it doesn't give you one, very pleasing shadows, and then two, there is not a lot of dimension that's being shown. We have a very harsh shadow right here. We could argue there's some dimension in the neck that is happening, but these shadows are very, very abrupt, and in general, were very flatly lit across large swaths of her face. And direct lighting is also not very aesthetically pleasing. Compare this to on the right when it's a much softer light and it's kind of nicely creating a gradient across her nose, across her cheek, across her chin. It feels much, much more cinematic than what we have on this left side here. And softening the light definitely helps create more gradients. So that's something to keep in mind. Imagine in this shot in Dune, if it was just flatly lit from directly behind the camera, it would not be nearly as aesthetically pleasing. And this one has really nice modeling and shaping of our scene coming from two different directions. We have the sunlight that is coming down and hitting many of our characters. Some are in shadow, but we're getting this nice hit over the top of them. But what is also great is we're also getting some shaping from the bounce of the sun that is coming up from the bottom. And that bounce is giving us some really nice gradients on the underside of our characters. It's a very soft light that helps reveal the form and gives us more and more gradients. Even the people who aren't in direct light are benefiting from that bounce soft light that's just causing those nice gradients. It's modeling them and it looks very, very nice. And it really just helps us understand these shapes more. Let's go ahead and look at an environmental example. In this image here, we don't really have a ton of shaping that's happening. We can tell that this house this barn. We have a little bit of shaping happening on the roof, but otherwise it's pretty flat. There's not a ton of drama in this. There's not a ton of shadowing that is going on. It's a little bit more of a boring image, but that is likely the intention of the shot. If the story you're trying to communicate is that this is just another day in a town, maybe making this too beautiful goes directly against the story point. Everything goes back to story. We don't want to make an image aesthetically pleasing with our lighting if that conflicts with the story. Everything goes back there. Compare this to our example on the right, when we have a very dramatic image that shows a lot of great shaping. We can see that throughout the mountains and these rocks here, a lot of the shaping that's happening. Without this light, this would just blend into the background. We have shaping on this big background mountain. We have this fog that helps shape this little rock formation. We have little shapes at the bottom here. We have shaping over here. We can really understand where we're looking because we have these nice shadow side lights. The exception to this little shaping rule is if you have silhouettes. Silhouettes don't really have any shaping at all. Maybe there's a little bit at the top from that light, but there's not any shading that's going on. And so typically the rest of the scene needs to make up for it. We need to feel depth. We need to feel the shape and modeling and dimension of the scene to make up for the lack of shaping in our subject. The same with this exorcist silhouette right here. We can really feel the three-dimensional nature through the fog. We can tell that this beam is coming in at an angle, and it's also helping shape the ground. We can feel how this looks. We're seeing it on the side, this nice modeling that's happening on the entryway. So if we don't have shaping on our subject because it's a silhouette, we do need it elsewhere in the scene. Imagine if we had a silhouette just in front of a flat blank wall. That maybe would be interesting in, say, a music video, but it's not very original or aesthetically pleasing. So it's important to have this modeling and shaping effect of our light to really reveal the three-dimensionality of the true three-dimensional scene that we're looking at. And, even in movies, when we have flat lighting, it's not really flat. We're still getting a ton of modeling that's happening in our light. We still have a lot of nice gradients that are coming across our character here. They're just much, much more subtle. And typically you need to have other aspects of your shot design and cinematography sort of make up for it when you don't have a ton of shaping in your scene. We have a very, very nice color palette here with a variety of pleasing color tones. In this image, we have very nice contrast that's separating our subject. And even though this is flat, overcast, we still have so much shaping in her cheeks. We're getting highlights here. We're getting reflections because her hair is wet. We're getting nice subtle rim lights on her shoulder. There's a lot of shaping and modeling happening on her face that makes it feel three-dimensional. It's not perfectly flat. You can really feel the way that the light is modeling Cillian Murphy's face. And even this, which again looks potentially a little bit flat, but there is very subtle gradients that are happening along the side of her head. The right side is much brighter than this side is. There's a little bit of a gradient going across her face this way. This is brighter than what we have here. There's a nice gradient across her forehead. So knowing that we're trying to model and show the three-dimensional nature of our subjects is very, very important to getting that cinematic look. So at this point, hopefully you have a good idea of what I mean when I say we are trying to model our scene with light and shadow. We are trying to use gradients to reveal the three-dimensional nature of what we have in front of our camera. That really helps make a cinematic image. Now let's move on to the next component, which is shaping the quality of our light. So what do I mean exactly when we're talking about the quality of our light? So ultimately it has to do with how harsh our shadows are. In this image, we can see we have very hard shadows on the left and very soft shadows on the right. And we mentioned soft shadows give really, really nice, aesthetically pleasing gradients. They're very flattering to the human face, where there's not a lot of gradients going on, at least in the direct shadow of a very hard light source. But, depending on what the mood calls for, harsh direct light is a tool. It's something that can be used to kind of make the image feel more raw and less beautiful. This feels more like a rom-com on the right, but on the left, this feels more like she's about to go on a mission, potentially to seek revenge. She's seeking trouble. And it's just all kind of influenced by the quality of the light. How soft are the shadows? And what exactly causes, the contrast in shadows? Why is this shadow so hard while this one is so soft? Well, one factor is the uniformity of our light rays. And we have a little diagram here on the left. This represents a light that would have very hard shadows. And on the right, this would have very soft shadows. This image has very, very uniform light rays. They're all facing the same direction, where in this soft light, they are going every which way. So let's say that our light has a value of 1 at each of these light rays. So as we start to hit our objects, we are getting, this ground is fully illuminated. And then if we were to continue this, it's getting blocked by our shadow caster. So that would get a value of 0. Over here would obviously be 1. This would be 1. This would be 1. So we'd have more zeros because we're not getting the light hitting. And this light ray would also have an intensity of 1. We are fully getting the illumination from that ray. And there's not really any way to cheat in any gradation in there, because all of these light rays are very, very uniform as they're being shot from the light. They are parallel with one another. And so it's very easy to predict, is the light directly hitting this object or not? And let's compare this with our soft light source over here. So in this example, just for the sake of having the same intensity of our light on the ground, let's say that every single light ray we shoot has a value of 0.2. So let's go ahead and kind of do a little bit of tracking here. This light ray is shooting, and we're going to hit right here. This is going to have a value of 0.2. We are getting one light ray that can hit this area. Then let's continue to scatter our rays. We will have one that can hit right here, and then maybe we'll scoot over a little bit and we just make it past, and it also goes over here. Now we have 2 light rays that can hit that same area. Now we have an intensity around 0.4. And then let's go all the way to the edge. I'll do a different color so it's just a little bit clearer. We go here, we go here, we go here. We're shooting all of these light rays because they're scattered on the light, and then we go here. We're getting 5 light rays. Everywhere on our light can see past the edge of the sphere right in that area. And so then we get a total value of 1. We're getting the full intensity of the light, because no matter what angle that this light shoots on this specific point, we can have the full light hit that area. And that's how we get that soft gradient, because where that 0.2 is, if we tried to draw from this corner to where our 0.2 is, it is getting blocked by our object here. This light ray is not able to illuminate the ground. It's blocked by our sphere. Another way that we can possibly think of this is if we were to draw a point from the ground, are the light rays scattered enough where this point would be able to see the entire light? And if we go in the middle here, this area is only to see roughly half of the light, and so it would only get half of the illumination. We're saying that this is how scattered our rays need to be to fully illuminate this point. And that just doesn't quite work when we have very uniform light sources. If we were to extend this light further out, because our light rays are uniform, we're not going to get this sort of overlapping gradation that we get in our example on the right. It's going to continue to follow a very uniform path. And so that is why the uniformity of our light rays is a very important contributing factor to how harsh or soft our shadows are. With that said, it is not the only factor that contributes to the harshness or softness of the shadow. It also has to deal with the size of the light relative to the size of the object casting the shadow. In this example, both of these objects have very scattered light rays. They're going every which way. But the light on our left is very tiny. And even though the light rays from here can shoot in any which direction, we're not getting any of that overlap that we talked about. The lights don't have enough room to navigate to do that same sort of crossover that we just talked about. And compare that over here where we have scattered lights on a larger source. We're getting these overlapping light rays again, which is causing our gradient in our shadow, causing very, very soft shadows. So these are the two primary reasons that a light has very harsh shadows or very soft shadows. It has to do with the relative size of the light compared to the object that it is casting a shadow from, and also with how uniform the light rays are. And the trend in movies currently is to kind of go more towards this soft lighting effect. This is very, very soft here, but it creates more aesthetically pleasing gradients and shadows. It's much more flattering to the actor or actress compared to a direct sunlight like this, a very direct, harsh source. You know, it shows every bump on the skin and it tends to feel much more raw than a soft light does. And remember, it's a gradient. We don't have to have one of these or the other. We can have a harsh light that has been softened a little bit. This feels very much like a rom-com. You know, I would say most films probably go somewhere in the middle between these. So let's take a look at some examples of direct lighting and soft lighting in films. So we have direct light here. I guess these are technically television shows, but you know, same difference. It's cinematic lighting. We are trying to really expose a moody, kind of gritty emotion here. Like I said, very raw. And the combination of this direct light with all of this contrast, as well as his facial expression, contributes to that. It's very desaturated overall. And this is a nice use of a direct light source. Contrast this with this image, we still have a very direct light source, but it feels much lighter because we have much less contrast in it. This feels like just another day in the life. And, you know, there's nothing super moody about this light source. It's supposed to feel regular, which if you've seen The Last of Us, you know that's exactly what the story is trying to reinforce. With her, again, very direct sunlight source. The sun is a very common use of hard light. Typically it's shaped a little bit, but like I said, there are reasons for having harsh lights. And in here, there is a very small artificial light that is somewhere off screen, and we can see just how harsh these shadows are on our character here. Again, it feels very raw and gritty. We have sunlight that is entering this room, creating very harsh shadows. And this still may feel a little bit like it's from an older film to you. And that is because older films, in addition to, you know, being shot on film and having a certain color palette, older films are known for using a ton of very hard lights. That's part of what gives them their aesthetic. And in here again, we have very, very harsh backlighting that's kind of on both the front and back of our character. If we look here, we can see the very harsh shadows that are being cast kind of across our characters, and it makes it feel much more gritty. And so when we zoom out here, we can notice a trend in pretty much every one of these images, minus maybe this one, and that is that the camera is on the shadow side of our primary light. And that just reinforces how often it's used to get nice modeling in the face. This one is maybe more from the side. Potentially this one is too. We have the nice Rembrandt triangle there. But the camera is just so often placed on the shadow side of our light, especially when we have more dramatic scenes. So now let's go ahead and talk about diffused light and bounced light. I want to talk about how we turn a hard light into a soft light a little bit more. So the sun has very, very parallel rays. We know that that is going to cause a hard shadow, in addition to the sun being very far away. And so relative to most of the objects, it is pretty small as well. So we get very harsh shadows. But When we start to scatter those rays, that's when we get soft shadows. And so when the sun goes through clouds, that heavily scatters the rays in many different directions, and it almost turns the cloud into a light in itself. It changes the size of the light, and it gives us an even softer look at a much lower intensity. And we can think of our ground in the same way. When our light rays hit the ground, we lose some of their intensity, but then it becomes scattered and shoots back up. So we can kind of see that overcast look in these images that we've already talked about previously that still show nice modeling in them. And we can also see examples of that soft bounced light effect. We can see the direct sunlight coming in through the window and hitting something off screen and bouncing back up towards our character. We can see the sun directly hitting his arm and his hand and his hair here, but we are getting that nice bounce on the inside of his face. Similar here. See the direct sun and the soft gradients on his face. Bounced lighting is used all the time on sets for trying to shape the light, for trying to get a little bit more fill in, and so it's an important concept to keep in mind. And I also have some examples here of hard light versus soft light that have very similar lighting angles, just so we can kind of compare the looks that it gives us, because this image on the right and left has a very similar light angle, but it just feels so much more raw and a little bit more old school with this hard light on the right. We can see every single pore on this guy's face. His eyes feel very, very sunken in compared to this softer top light on the left here. It's much more flattering to our actor, and through his stare, we're still able to feel, maybe a sense of intimidation because of the direction of the light, but the softness just makes it a little bit less harsh to look at, a little bit less raw on the left here. And this is another example where I think similar light angles are used, but there's a very different effect. This feels much more terrifying, not only because of her look, but because the hard light is accenting every wrinkle in this character's face, where over here, it's much softer, it's much more flattering, and it's just interesting that both of these also have our Rembrandt triangle as well, but the emotional effect that the lighting has on us is very, very different, and that's just because the light is soft rather than hard. And so we've seen this example, feels more raw versus more of a rom-com. And even in environmental work, you can really use this to communicate parts of a story. In Dune, this is the water planet that they live on before they move to the dry desert planet. And the water planet has very soft lighting throughout. There's enough moisture in the air to have the clouds block the sun and have this very soft overcast lighting, compared to Dune, which feels very raw and exposed to the elements, and the hard lighting really helps reinforce that. And so kind of keeping in mind the emotion you're going for in environment shots, as well as any sort of character lighting you're doing in CG, is very, very important. And when it comes to choosing hard light or soft light, you don't just have to use one or the other. It's very common to use both in conjunction with one another. We can see that on Leonardo DiCaprio here. We have a very, very hard rim light on both sides of his face. But then what they do is take a very, very soft light to kind of fill in the gradient. Otherwise, this would all be left in shadow and in silhouette, and it's creating these nice shapes across his face. And so using both in conjunction with one another is very, very common. So it's definitely a tool that we can use. Now, I want to take this to segue into a related topic to everything that we've been talking about, which is that films typically use motivated lighting, not necessarily realistic lighting. This right here is what this room realistically looks like, but it does not look and feel cinematic like this right here. Films use a variety of tools to shape their light to get those nice gradients. And we're going to go through a couple examples of what that looks like on a film set here. So if we were to just shoot in an overcast lighting environment right here, this is what it would look like, our character right here. It's fairly pleasing, but there's not a lot of shape to our character's face. But as we add a big black piece of fabric to the side of our character's face, notice how much more shading we start to get. That is called negative fill, when we are essentially adding a giant black square just off frame. And what it is doing is hiding all of that bounced light that we would typically get from the ground or anywhere else in our scene. It is blocking it so it can't reach his face. So it's almost like the inverse of lighting, where what we are actually doing is removing light on this side of his face, trying to get those nice gradients. And it says here, this is with the flag at 45 degrees, so it's probably a little bit more canted than I drew it here. And this is with the negative fill at 90 degrees right next to him. And so using negative fill is a great way to shape your image and make gradients. It still feels motivated, but it feels just a little bit more rounded. It feels like maybe with the overcast sky, the sun is in a little bit more of a direction this way rather than just completely ambiently lighting our whole scene. And so keep that negative fill concept in mind as we look at some of these other images. So this right here feels pretty nice and cinematic to me. And if we take a look at what they actually did, is they had the sun shooting through to our character, but they actually put diffusion in front of it to soften the shadows a little bit. And in order to enhance the shadows even more, they put a black negative fill just off to the right, so we get this nice contrast. And it looks like their ground was also kicking up too much bounce on the underside of his face. And so they put kind of a not quite full negative fill, but a gray blanket underneath him so that they would get a little bounce, but not a ton. And so when we talk about shaping the light, this is what we are doing. We are softening it and then removing ambient bounce with negative fills of different levels. And something that is important to keep in mind is that our bounced light is going to return different amounts of energy based off of how bright or dark the material is. If we have a bright white material, it is going to bounce back a lot more of the light than, say, a black or gray material would. Maybe gray is going to bounce back maybe half as much, and then as we get a black material, our light is going to be mostly absorbed. You know, maybe there will be an occasional little bit, but it's going to absorb most of the energy. So we can use white bounce to add light and add very soft lighting effects for our gradients, gray to kind of be somewhere in the middle, and then a dark black for absorbing most of the light and creating a pure negative fill. So keep that in mind as we think about bounces. And we can absolutely do this in 3D, and we'll definitely look into doing it. Another example of shooting outside, this one, they're not using the sun and shaping it. This is kind of a sunsetty environment. The sun is no longer out. Our character would likely be in this sort of tone for the whole image. If we didn't do this light shaping, they added a bright LED light through here and they shot it through diffusion to get this really nice soft roll off. If they were to take away the diffusion right here, it wouldn't necessarily feel motivated because we wouldn't really get a sharp light like that with this type of background. It would feel very out of place, but because they shot it through this diffusion that is softening the light so much, it just looks like the overcast is a little bit more powerful in this direction. So it feels realistic and it feels motivated, even though it's technically not would really be there. And we can also see that they have two pieces of negative fill on his right side as well to further increase the contrast. So they are shaping the light here in a way that I think is very successful and feels very dramatic. And shining in through this window in Handmaiden's Tale, we can take a look. It looks like there's just one light shining inside, but there's actually, I think, 4 sources going on through here. And so if we were to just kind of illuminate it, we have one main source coming in through the window that's giving us these nice, very sharp shadows. And then they're shooting very, very bright lights into a bounced source right here. And this bounce light is very soft and it helps kind of illuminate the side of our panel here, and it kind of helps wrap around and fill the room. And additionally, they have more soft ambient light coming in through this direction. If we just had this light, this would likely be a shot in silhouette, but because of all of this bounce, we are able to get nice gradients. We're able to see what's going on, and they shaped the light very nicely here. And it looks like there's even another light that I didn't see when I first initially looked at this graph. There is a big LED light that is shining down very close to the top of the window, and I think that is catching her shoulder blades, her collarbone a little bit, and just helping those pop. And, as you dive into more and more examples, you can see just how crazy some people get with shaping the light. This looks like they just shot it in daylight, but they used these two nets right here to cut down the intensity of the sunlight. There's negative fill next to Will Smith. They have two bounces here to kind of fill in more areas that they want to try to get this shaping. And so there's a lot that goes into turning an image from something like this to this over here. I would also probably argue in some of our bounced examples, they probably have a piece of whiteboard over here to increase the intensity of the bounce, because this is bouncing quite a bit. All of these images we have been going through certainly have some sort of light shaping happening through one means or the other. And that's what's important to keep in mind. We're trying to have it feel motivated, but not truly realistic to real life. And this kind of becomes a question for us as we're doing visual effects lighting, because we are trying to get it to feel realistic, but we're also trying to get it to feel cinematic. So often we're having to kind of balance these two thoughts and ideas as we're lighting. And so we'll go ahead and cover that more as we start lighting in 3D, but it's just something to keep in the back of your mind as we continue talking about lighting throughout this course. We're going for motivated lighting, not necessarily true to life, 100% realistic lighting, because that isn't as cinematic. And now let's move on to our third component of creating an aesthetically appealing image, and that is creating a pleasing contrast and color palette. We've talked about contrast a bit already in these videos in terms of subject separation. It's important in terms of telling our story with how dramatic it feels, but it's also important in terms of just creating a nice aesthetic. If we have too little contrast, our image risks becoming washed out without much modeling, and too much contrast, parts of our image will be unreadably dark. So let's take a look at some examples to kind of dive in what we're talking about here. So this is our contrast ratio, and that is talking about compared to our primary light, how much fill are we getting? So in this example here, the ratio is 1:1, and it's very flat. There's not a lot of modeling in here. Here we have a ratio of 2:1, where the light over here on the bright side is twice as bright as what we have here. 4:1, this is 25% the power. 8:1, 12.5%, and so on. And you can see as we go down this scale, we start to get more and more modeling, but it also starts to feel more and more dramatic. So I'd say most movies probably kind of sit within this realm for their contrast ratio and modeling, but it all depends on your story. And I would say commercials probably cheat more towards this area. Let's take a look at some examples of different contrast ratios. So here we have the two kind of main groups that are typically used. We have high key contrast ratios and low key. So high key contrast is really saying that there is less contrast throughout our scene in general. There is less contrast between our darker tones and our lightest areas. Where in low key lighting, we have greater contrast between the dark and light areas. And we can see here the two very different feelings that we get from high key and low key lighting. Commercials use very high key lighting. It's very bright. Everything is nicely and pleasantly illuminated, so the product feels very friendly. And depending on what mood and emotion you're going for, high key lighting can work really well to kind of have a nice, pleasant, soft, exciting image. There's nothing too dramatic in high key images. They just kind of feel nice and pleasing. Compare that with low-key images, and these feel very, very dark and dramatic. The contrast ratios are turned up to the extreme, and that's how we really get a lot of drama and mood within here. And even this example, which doesn't necessarily have a super bright light source, we do have a lot of contrast just in terms of the sky compared to our two subjects here. This is from Arrival, where we have our character very nicely silhouetted by the sky as well as this alien spaceship. And we still have modeling on our character's face. We can see the shape. It's just very, very subtly done over here. And so this has generally low contrast in terms of its lighting, but it still feels very contrasty because it's more silhouetted. And so in terms of contrast, it's a little bit of a tricky one because it affects everything that we've talked about so far. It affects the story and emotion of what we're looking at. It affects subject separation, and it definitely affects having an aesthetically appealing image. Generally, you want some level of contrast sort of in these like middle zones so that you get nice shaping. That's really what it's trying to support in terms of an aesthetically pleasing image. That's not to say you can't super crank your contrast like in this image here, but when that's done, that's more so for a story point. This character is a psychopath in No Country for Old Men, and we don't see any modeling on the left side of his face, and that makes him feel more evil and more just kind of dead on the inside, that we can't see any shaping there. All of these other examples, we can see shaping however subtle it may be, and so making sure that we have some sort of shaping in our contrast is certainly very important. We don't want it to be flat and washed out. Even these commercials have a lot of subtle shaping kind of going on, some more than others, but that's what helps make a cinematic image. And having a high key image also doesn't mean that you can't have contrast in it. It just means that our darkest darks are much more lifted than they would be compared to a low key image. And there is certainly a middle ground between high key and low key lighting. An overcast environment is a good example that kind of sits in between high key and low key. If we look at kind of our diffused light, I would say, some of these kind of sit more in the middle between the two of them. So it doesn't have to be one or the other. This is a spectrum that we can slide between. So now let's move on to talking about color. Color, when we shoot, it has big implications in terms of story, how we feel emotionally. It also has implications in terms of where we think we are spatially, because we are familiar with the color of certain things in our environment. We know that light bulbs are typically on the warmer end of the spectrum of color temperature. This is the Kelvin spectrum of color temperature here, where we get our very warm tungsten film lights typically sit around here. Daylight sits around this area. Overcast starts to sit more around 8,000 Kelvin. And so a lot of lighting color is based off of these sort of natural and common artificial lights. We can kind of see the sliding scale as we move up and down the image. We have very, very warm lighting on the lower end of our color temperature. And even sunsets start to move down here. And as we start to move, LED lights and maybe like I call these like gym lights start to feel more and more neutral and white. And we can see all of that reflected in how it's lighting our characters. And then as we start to get more into daylight, we start to get a little bit cooler and more desaturated in sort of this area. And we just get cooler and cooler as we move into these more overcast environments. And part of our color also has to deal with color grading. We can have these kind of neutral lights, but then in the color grade tint it green. But these lights are certainly being played as white. It's more in the midtones where this color is done. The lights themselves are not actually green. So color grade also has a bit to play into our aesthetics. But typically what we'll see in movies and TV are lights that are based on the Kelvin scale, this Kelvin color temperature. And so if you hear someone say that light is 3,200 degrees or 5,600 degrees, it's like roughly daylight versus a tungsten light. And anything that kind of sits outside of this in a very saturated sense starts to feel much more stylized. It doesn't quite feel as realistic to the audience. So again, this is an aesthetic choice, which can look very cool. But I think you need to be very careful about employing these super bright saturated lights, because they definitely have a certain look to them, which maybe doesn't feel as natural as you want, but it all depends on the story. And you can also use nice complementary colors to create just a nice natural color palette. A huge trend that's kind of come and gone in recent years is the blue orange kind of color grade. And this isn't necessarily done by the lighting. A lot of the times it's done in the grade overall, but humans have warmer skin tones and the sky typically has more blue in it. And so this is a very common complementary color scheme along with green and red. It also looks nice. This one is a little bit more desaturated. purple into yellow, a little bit more on orange. These again start to feel pretty stylized when you use them. They do complement each other nicely. That's why they're complementary colors. But most of the lights that we'll see in films kind of sit within this Kelvin temperature scale. So a lot of the times we kind of start using these unless we know it is a super stylized show and we can use some of those crazier colors. And so that wraps up our chapter in cinematic lighting principles. These are the baseline ideas that we need to keep in mind whenever we're lighting a shot. We need to first and foremost communicate the emotion, mood, and story of the scene. That always comes first at the expense of everything else. Then we need to make sure that we direct the audience's eye through contrast. It should be very clear and apparent through our lighting, through our framing, what is the subject of the shot and what we should be looking at. And then finally, we want to create an aesthetically pleasing image, assuming it doesn't conflict with our first two goals. We want to make sure that we are modeling our subject or scene with light and shadow. We want to make sure we're getting those really nice gradients. We want to shape the quality of our light in order to help with that modeling. We want to control the shadows and the overall quality of our light source. And then finally, we want to create a pleasing contrast and color palette. In terms of contrast, that will largely be driven by the emotion, mood, and story, drawing our eye, but we also want to make sure we're using our contrast to the best degree that we can to get those nice gradients to model our image in a way that feels nice. And we can use our color palette, our different Kelvin temperatures, to help inform the audience a bit of the mood, a little bit of what the light sources could look like that they're coming from. We could have the really warm 3200 degree lights, we could have the very cool overcast lighting, or very stylized lighting. It all depends off of the mood and story of the scene. And so in our next video, we are going to take a look at applying some of these cinematic lighting principles, and we're going to actually find out what tools do we have in Houdini to start using these and put them in action practically. So thank you so much for listening, and I'll catch you in the next one. Hello there, and welcome back. In this video, we're going to start to dive into some of the lighting tools that are available to us in Houdini Solaris. It's important to know what exactly we have in our tool belt when it comes to trying to achieve our 3 cinematic lighting goals. So let's go ahead and hop right in. So we have a very basic scene set up for us. This is also available to you in the example files folder, and you can follow along if you'd like, but we have a very simple scene just to kind of show off some of the ground level lighting tools that we have available. We're going to quickly run through the different lights that we can create in Solaris because, some of us will probably be familiar with most of these, but controls have moved around a little bit, and I just wanted to run through them quickly so we all have that same foundational step underway. So to start off with, we have the humble point light. The point light is an infinitely small light which casts very, very hard shadows. We can see that this is tack sharp. We can see every edge of our imperfect geometry. And unlike in normal Houdini, we can't scale our point light up. It is always going to be infinitely small. And we also aren't able to render it because, again, it's an infinitely small light. We can actually see it reflecting here, but we can't get it to render in itself. And this point light looks the same between Karma XPU and Arnold. If I were to just swap over, we can actually see something very nice, which is that these lights have a lot of universal controls. That's everything that exists in the base properties and transform. You can be pretty confident that between render engines, these will all function in the same way. And so back to Karma XPU. So how do we scale up our point light so it's not infinitely small? Well, that is simply a different light type in Solaris. Instead of point light, it is a sphere light, which I've just quickly made here. So now we have that radius control that we are probably very familiar with. And we can see that as we scale this up, our scene is actually getting brighter. And that is because normalized power is not turned on. If we were to turn normalized power on, we would see a different behavior. Now when our light gets bigger, we can see the light source itself feels much dimmer, it's much darker, but the intensity on our surrounding scene is around the same, shadows notwithstanding. But we can see now as we scale this up and down, our surrounding area stays pretty consistent. And I think normalized power is very, very handy to use because a lot of the time when I am scaling our light up and down, I'm really just trying to affect the softness of the shadows, and I don't really want to affect the overall exposure. So normalized power is definitely important to keep track of. Up next, we have the cylinder light. Some people may call this a tube light, but it is a wonderful light that allows us to make a tube of light. And there is a very interesting sort of property with cylinder lights, and that is that they don't emit out of their sides. We can see this kind of dark spot right around here. All the lighting that we're actually getting on our character here is bounce light. In fact, let's prove that. Let's just turn off of our set really quick, and we can see that we're not actually emitting any light directly out the sides. It's almost like a little bit more of a focused sphere light, and we can control the radius and the length of it right here. And this behaves, for the most part, very similarly between Karma and Arnold. Something that you will notice if we switch over to Arnold right here is that instead of rendering black on the inside, Arnold lets you see through it. They're both weird. I don't really have a preference for one over the other because I think they're both technically incorrect, but that is something that is good to be aware of. Up next, we have a bread and butter light. We have a disc light, which we can see right here, and it is shooting outward with a disc form. And this is very, very similar to a area light or a rectangular light, as it is called in Solaris. So we can see rectangle and disc right there, and they behave very, very similarly to one another. If I were to swap between these, you can see there is very, very little difference between them at the first glance. As we kind of look through here, you can see that the disc light maybe doesn't quite cover quite as much area, but this is good for throwing inside round engines, things like that, but they behave very, very similarly. We can use the width and height sliders to make it larger for softer shadows, or make it very, very tiny so that the shadow is harder. And by default, these will be very, very soft light sources. If I were to rotate this around 90 degrees, we can see the light is very, very soft on our background. And we are actually able to control the spread of this light. And, we talked about how uniform light rays really give us nice, sharp shadows. So let's actually prove that. In the Karma tab here, we have a Karma specific setting called spread, and as we start to take this down, we'll notice that the light shoots out in a much more straight way, and we're getting much, much sharper shadows and much more intense light. And if we were to make this 0, we can see it is basically a perfect rectangular spotlight here. And so this spread is a control that we not only have in Karma, but it's something that we also have available to us in Arnold. So let's just switch over really quickly. All right, so within our Arnold tab, we have the exact same control. We have a spread, and as we start to bring this inwards, we can see a similar effect happening here. Arnold does have a nice little soft edge control as well, which I do really like. It kind of softens the fall off, so as we get more towards the center, the light is a little bit more intense. It is a nice touch there. But, disc lights and area lights behave very, very similarly. And there is a little bit of a difference between Karma and Arnold. So within Karma, if we were to switch back, let's just take a look. Again, we can see that this light has a backing to it, where in Arnold, it does not. There's still some double-sided light render issues in Arnold. But as we take a look here, we are only emitting forward-facing light. But within Karma, we can activate this attribute, which determines whether or not we're using single-sided light. And so we can see here as we enable single-sided, that is the default and it points this way. As we turn it off, we now have a double-sided light. If we take a look at our disc light, we should be able to see the exact same thing happen. Let's go ahead, turn this on. And we can see we again have a double-sided light right here. With Arnold's current implementation, we don't have that double-sided checkbox, so we're not able to turn it on. So that is one of the limitations of Arnold currently. Now, the next light that I want to take a look at is the distant light. With the distant light, it is very important to have normalized power on so we're getting our correct exposure, but the distant light simulates an infinitely far away light, and we can control the sharpness of the shadows with this angle here. And so we can see those getting softer and softer as it goes away, and this is used most of the time to imitate the sun, which is very, very far away and would have very parallel shadows. So distant lights are a nice, healthy tool, and we can swap between any of these lights we've gone through so far just with this little type switch here. We can see we can make all of them with the exact same light node. Now, while looking through this dropdown, it may feel like we are missing a key light. Where is the spotlight? Well, spotlights in Solaris work a little bit differently. Let's take a look at this one right here. So we can see that our spotlight is actually a rectangle, and we can see the rectangle presented right here. But we have this additional shaping tab, and this is how we can turn a light into a spotlight. And so we can see our familiar spotlight settings here. We can affect the angle so that it is spread a certain amount. We can have the edge softness be cheated on the inside and the outside. And we even have these handy left barn door buttons right here. It takes a second for the GPU to recompile to load these because it is technically loading something slightly new. So you might see a little bit of a hiccup when you first try to move this barn door, but let's just give it a second to load. And now we can see we can just start to very quickly close off different parts of our spotlight. We can come from the left side, we can start to come in from the right side, we can come in from the top, and we can also control the softness of our barn door edge. Now this is a little bit hard to see with a rectangle because the rays that are shooting out are spreading quite a bit. So let's actually change this to a point light. All right, now we have our infinitely hard shadows, and we can start to see the edge now get softer and softer as we start to increase this parameter. And so we can turn that off entirely. Let's just get rid of all of these barn door edges, and we have our nice spotlight loaded up in here. But remember, since this is a point light, we can't exactly soften the shadow. We can't scale it up. So we can also use a sphere light as a spotlight. And now, through the radius of our sphere, we can actually start to control the softness of our spot shadows. And we don't want this in here anymore. I don't want to render this light geometry, so let me just turn that off. Great. Let's also hide it from our viewport with this display light guides right here. So now we can see we are adjusting the softness of our shadows, the softness of the edge of our spotlight cone. Very, very handy. Let's go ahead and make this just a little bit brighter. Maybe we can make this a little bit sharper as well. Just adjusting the radius of our sphere. And we can see it's pretty tiny now. We can also see the angle adjust in our viewport as we start to tweak this. So the spotlight tab is really, really handy, but there is also this excellent focus tab. And I really, really like what this does. As we start to turn the focus up, it is going to bias more and more light into the center of our spot. And we can also tint the focus, and I really enjoy tinting the focus. Let's go ahead and do that really quick. But we can actually use this little outside area and give it an interesting color. And I think that just helps add a little bit of imperfection, a nice little amount of realism into the spotlight, and we can continue to control the other components of it. But I really like using the focus and spotlight tabs. These are much more fleshed out in Karma XPU than they are in Arnold. Arnold doesn't work with this focus tab at all, and Arnold does not use these barn doors effectively. You have to go through the Arnold barn door system, which we can go over once we start talking about light filters. But we can see it does respect the softness tab and the angle tab, so we are able to use these to control our spotlights. So that sums up all of the lights that we can just make with a normal light node. From this drop down, we can go ahead and make point lights, sphere lights, cylinder lights, disc lights, area lights, spotlights, and distant lights. And so let's move on into our dome light territory. Dome light is a separate node that we cannot make from that drop down, and we've already used this in our first intro to Solaris video, but dome lights are used primarily for bringing in HDRs. And we can see here it's reflecting throughout our scene. There's nothing too special about being in here. You know, I'm not sure this normalize filter really does anything because our dome light is always infinitely large. It is infinitely far away from all of our objects, and we're definitely going to touch on that property when we start talking about spatial lighting. But yeah, there's nothing too special about the dome light in Solaris that we haven't covered already, at least. You know, if we go to Arnold, we'll see it looks largely the same, minus some brightness differences in our background, and we've went over that already. It's because we have the environment lights displayed as the background. If we go back to Karma XPU, we'll see that we'll have to turn render light geometry on. You know, we've been over this already, but we can see it looks very, very similar between our two different render engines. The one thing to keep in mind is that with Arnold, we need that set to lat long and not automatic, because otherwise we get these really, really weird stretched HDRIs. But otherwise, nothing too fancy in our dome lights here. So let's go ahead and switch back to Karma XPU, and let's take a look at kind of a fun node. We have this Karma Physical Sky. And this node is useful for simulating different times of day when you don't have an HDRI handy and you just want something quick to kind of approximate what it looks like perhaps when we're at noon and the sun is directly overhead. We can kind of control how clear the sky is, how much, you know, sort of humidity and particles are in it with this turbidity. We can get a couple different looks here, and it's just nice for quickly at a glance seeing what different times of day like. And as this gets lower and lower, you can get pretty nice sunset effects. I would only recommend this typically just for like asset work and look dev, just because most of the time you want to be using an actual HDRI, so we're getting all of the nice natural reflections and not just kind of this weird blank reflection in here, and just kind of more real world accurate lighting data. This is just more of an approximation. But we can control the sun independently if we like. We can see the sun getting larger and larger in the reflection here, and we can also see that when we decrease the size, the shadows start to get sharper. This should be very familiar to us. And we can turn off the sun if we don't want it. We have our independent sun controls. We have sky controls, you know, kind of how much particulate there is in the air that we can adjust. We can have just the overcast kind of sky in here. If we start to turn our turbidity down and increase the exposure, this starts to feel more like an overcast day that we can simulate, especially, you know, if we bring our solar altitude a little bit higher. So this feels nice and overcast. We also have this option to try to use a specific location, date, and time. I think this is a little bit gimmicky to me personally. Like, I'm not sure what the real world solution for this is. It seems like it's more trouble than it's worth if you're trying to calculate the exact time of day you shot something. But maybe if you want an approximation for what does it look like at 7, this is useful. So we have this tool, and as you can expect, this only works in Karma. This does not work in Arnold, but I don't think that's too big of a deal because really we should be using HDRIs to light our scenes anyways. So now at this point, we've covered our large scale environmental lights. We've covered our main lights we can make with the light node. Let's go ahead and talk about the last type of light we can create, which is the mesh light. So I'm just turning off the headlight here just so we can see the wonderful light emitting from our little rubber toy asset right here. So geometry lights are pretty inefficient overall. They definitely can slow renderers down, and they're just a little bit painful and tricky to deal with. You know, it is technically working, but it takes a while to clean up some of the noise done by mesh lights. So let's go ahead and chat about it. So the first thing you need to do is assign an emissive material to your geometry object, which I have done right here. It is emitting this blue checkerboard. So that is step one. That is complete. When we talk about materials, you'll learn how to do that. It's pretty easy. And then you need to create a render geometry settings node. Now this is a brand new node that we have not covered yet. So the render geometry settings node describes properties to be interpreted by each of the individual render engines. So we can see with Arnold here, we have our familiar geometry object properties. As we kind of scroll through, we have displacement settings, we have subdivision, and so on. And within Karma, we also have settings that tell the renderer how to look at our object. And so in order to set our geometry up to be a mesh light, we need to scroll all the way down and just turn on geometry light here. And then we can start to try and enable some familiar settings. We can start to turn the exposure up of our light, but we will notice a problem. We will notice a current limitation of Arnold and Solaris. We're not able to get that full texture in through our light right here. If we were to enable this, we can change the emission of our light, and we could probably sample and try to get it something close. We'll kind of saturate it up. We can tweak it a little bit, but it's not going to be 100% accurate, especially if this was an intricate pattern. So that is definitely an issue with the current system. We can't replace this color with a more intricate texture. But what about Karma? What if we switch to Karma? What do we need to do there? So if we go ahead, go back into our Karma tab, and if we scroll down, we will see a very similar parameter, which is named treat as light source. We have it set to yes. And if we change this between yes and no, it doesn't really look that different. What it is trying to do is sample it more efficiently when we turn this on to yes. And so that's why we want to turn that on our object within Karma, but we don't have any exposure settings within here. So how would we adjust that? Well, in order to adjust that, we would actually have to go into our material and tweak that. So if we expand our blue checker here, we can kind of see everything that's going into it. And if we look at our surface, we can actually kind of see all of the different settings we are currently using, and we have this emission. So we could right click, edit property, and increase the intensity of our light this way. And we are able to get this nice pattern. If this was, blue on one half, green on the other, we would get that in this render, but it renders very, very slowly and samples slowly compared to other lights. So I would say try to not use geometry lights unless you absolutely have to. And we could use this same emission trick to technically get our texture lighting the scene in Arnold, but with Arnold, lighting through emission is incredibly slow and incredibly noisy, and it just isn't really a good idea. So I would try to avoid using mesh lights wherever possible. And so that sums up our basic lights that we can use in Solaris. Now let's move on to our next video where we're going to talk about the theory and practical application of using these tools and lighting a scene. Thanks so much for listening, and I'll catch you in the next one. Hello there and welcome back. In this video, we are going to start to dive into the theoretical and practical application of using our lights within Houdini. In the previous video, we talked a little bit about what those basic light types are, but now I want to talk more about how we can actually use them. So let's go ahead, dive in, and get started. So when it comes to using our lights, there is a fundamental decision that we need to make at the start of our process, and that is the light positioning. The light positioning has a huge impact on the overall emotional and narrative response to the lighting of our scene. And we can see just how different each of these pictures feel. This top row has all of the images where the light is slightly higher, shooting down at a 45-degree angle. This middle row has it at the same height as the camera, And this bottom row has the light shooting upwards and causing some upward facing shadows. And we can see even when the light is directly in line with the camera, we have very, very different emotional responses. This feels very unsettling when the light is shooting straight up compared to when it is shooting down. This feels potentially a little bit sinister, but it doesn't feel nearly as off-putting as shooting the light up. Shooting the light straight at our character very much washes him out and doesn't feel very cinematic, but you can see as we start to get to more and more extreme angles, our response to it feels more and more extreme. It doesn't feel quite happy-go-lucky once we start to get to these incredibly glancing angles. Now, part of that also has to do with the amount of contrast in our scene, so let's actually take a look at some different examples. So when the light is shooting directly behind and not really illuminating our character at all, obviously this has a very, very dramatic response. As the light is shooting up and casting those shadows sort of into the sockets of our character's eyes right here, it feels very, very unsettling. And part of what determines how unsettling it feels is the quality of the light. We can see shooting up with very, very harsh shadows really accents the kind of dark tones we get around the eyes and the nose right here. Where when it's a softer light, instead of feeling unsettling, it turns into more of a nervous feeling. You can feel that here as well, where it's a little bit in between these two, and again, very soft light, so it doesn't feel nearly as dramatic as what we have in these two images. When the light is shooting from the top down, it can feel a little bit more like the character is being exposed. It can feel, maybe a little more haggard. It's definitely very dramatic, especially as our contrast ratio goes up. But there's a very big difference between just the vertical position of our light, as we can see between these types of shots. And as we start to swing our key light, our primary light around, it starts to get less and less dramatic. These are lit largely from the side. There's not a lot of light kind of wrapping around the front of our characters' faces here, and these start to feel more dramatic. And that is why commercials typically have, very nice, flattering light that is wrapping around most of the face, very low contrast. It feels much less dramatic, as we can see in all of these examples. And I think this is an interesting example from No Country for Old Men, because they intentionally shot this with very boring flat lighting, because it's supposed to look like an average everyday scene. It's not supposed to look out of the normal. It's supposed to feel like something we should feel in real life, which makes it more unsettling when he goes and kills a character later in this scene. It's all done for narrative purposes. So knowing the light position and angle and the motivation for that light is our first fundamental step for really setting up our lighting scene within Houdini. So let's go ahead and hop into Houdini and take a look at doing that quick. So we have a blank scene right here. Let's just make a test character that we can show off some of our nice tools on. So I'll just type in test, and we can create a test template body. And let's also give him a ground plane. So we can make a grid and put that down. And once we connect these, we can go into our Karma XPU, and now we have a render going. So let's add a light into our scene. We'll add a light right here. All right, and let's make this a area light or a rectangle light. So in order to position the light, there's a couple different approaches that we could take. One way of doing this, of course, would be just to move the light around with our handles, but this can be a little bit tedious to do and kind of a pain, so I don't really enjoy doing it this way. Another way that people traditionally light is look through the light itself and then start to maneuver it that way. Now within Solaris, you actually need a second viewer for this to work 100% correctly, so let's just take a look at that here. We'll create a new scene viewer. And then with our camera drop down, we will look through our light, and then we will lock the camera or light to our view. And now we can start to move this light around and get our scene illuminated. Now, this works fine and is nice and all, but Solaris has introduced some tools that are much, much more useful than just kind of dragging around in our viewer here. And those tools are our placement modes. And so if I were to select this diffuse placement mode, now anywhere I click on our character or the ground, it is going to angle the light in line with that normal. So if I wanted to directly illuminate the top of his head, I simply need to click on the top of his head and it will snap the light into the correct position. We can see it moving in our viewport right here. And so that is very, very handy. It's much easier to do this than to try to maneuver the light around to exactly where we want it to be. And there's also some other nice functionality with this tool. We can not only place the diffuse, but we can also place where we want our shadow to go. Now let's have our light create a very, very harsh shadow just for illustration purposes. We will change the spread to 0.1. All right, that is certainly something that we are seeing on our character here. We'll change that to 0, and maybe we can just make our light a little bit bigger. So what we can actually do with our shadow placement mode selected is click to set our pivot. This is where the light is hitting, and then shift click to determine where the shadow is going on the ground. And this is a really handy tool because a mentor once said to me, light is more about placing shadows than placing light. And this allows you to control that very, very well and easily. We're able to point our light exactly where it needs to go to cast the shadow that we want for our scene. So let's go back to the diffuse tool temporarily, and let's also, fix the spread just because this looks pretty weird at the moment. All right, so we have our diffuse tool, and we can not only affect the position, but we can also affect the light distance. So as I control, click, and drag, it is moving our light further and further away, but it is keeping the angle exactly the same. And so that is something that is very, very handy. And we can see that as we move our light further and further away, our shadow is getting much, much harder. Let's go ahead and move our light back, have it be closer. And I'm going off screen here, but as we get very close, we can see that shadow get very, very soft. And as we go further away, we can see it get very, very hard. And we can control how fast our light distance moves with this increment. If we just scroll our middle mouse wheel, we can see that change. And now it's going to go away much, much faster and come closer much, much faster. And so we can also, as we can see with our little tooltip here, we can change the brightness. Control Shift left click, and we can change the intensity. We can use our middle mouse wheel to, again, adjust this. I don't really like using the intensity slider, but that is what this uses currently. I wish I could change it to exposure, but I will deal with the cards that I am dealt. And this functionality also works with our shadow pivot mode. If we just click back here, we can Control Shift, we see the intensity changes. And we can also just control click and we can see the distance changes. So that is a really nice tool for controlling the position of our lights. We are also able to use this tool to, say, place lights very close to the ground easily. Let's go ahead and take a look at doing that. Maybe we can change this to a sphere light, and we can make it pretty small, and you can see our intensity has changed because that's what our Control Shift click adjustment changes, our intensity, not our exposure. But we can go ahead and determine a fixed distance for this light to appear. So with fixed distance on and diffuse selected, when we click the ground, it is going to place it right above the ground that we have selected. And so it's very easy to place lights on the ground just like this, and we can have it be as high up as we want, and it will float a little bit above the ground. If we want it 1 meter above the ground, we can see it floats perfectly like that. And we can also tell it to keep its orientation. If this is rotated in a certain way, this would be more obvious if it were, say, a cylinder light. We can tell it to keep its orientation no matter where we are placing it. Take the exposure down some. I don't think normalized power is turned on. That's why it's getting so bright. But if we were to not check keep orientation, we can see that it's orienting itself based on the normal. But if we were to keep orientation and put this at its original spot. We can see it's only moving the position and not the orientation of our light. So now let's talk about our next option here, this specular placement mode. So we probably need a little bit of a better material to really see the effects that this has. So let's actually look into creating a material for our character very quickly. So in order to make materials within Solaris, we need to create a material library. And if we dive inside, this will look like a very familiar matte context to us. It is very similar to this guy right here. So when we dive inside our material library, we can make a Karma material builder, and this will set up a Material X material for us. Now, I don't want to dive into anything too deep here. All we need to know is that with our material standard surface, let's turn the metalness all the way up, and maybe we can turn some of our roughness down to 0.1, and we can just name this our metal material. And so when we go back up to our stage context, we can see that we are creating a materials scope. And within this, we have our metal material. We are loading in all materials, that's our asterisk wildcard, that have this output selected. If we were to uncheck this, we would see there are no materials being loaded in. So there's a couple different ways we could assign this to our geometry. The easiest for right now is just click Assign to Geometry, and then we can drag and drop our template body. And so now we can see we have our metallic man, and this will be much easier to see what our specular placement tool does. So let's change this back into, let's say, a sphere. Something small like that. So now what we can do with our specular is wherever we place this, we are going to get a specular reflection on that exact location. And this is really, really good for placing tiny lights that catch the eye, often in the eye as a catch light. This tool is excellent for adding glints and just really helps bring shots to life. If we take a look at some examples here, this is referred to as a catch light when you have this tiny, tiny little eye light in here, and it really just helps bring a lot of life to the eyes and to the characters. You can see that without it, it feels much more contemplative and potentially more sinister because they're kind of missing that life, and it makes them feel a little bit more dead behind the eyes. And catch lights, specular lighting also helps add glints and continues to bring things to life that way. Lots of good glints in this shot from Rogue One that just help, really reinforce the hot ping of the sun. This helps add a lot of visual interest. We can see the specular here. And just adding these nice little glints are just really good touches to help bring shots to life. I keep saying that, but it's because it is very, very true. Glints help things feel realistic. You just have to be careful to not go too overboard with them. So using our spec placement tool is very, very useful for that. So that covers our tools in terms of our light position / angle. Let's go ahead and talk about the light quality. We've already talked about how we can implement hard light versus soft light in Houdini. It's pretty straightforward. The bigger that our light is, the softer that our shadows will be, and it's all about the relative size of our light. We can have a very big light, but as we move it further away by holding Control and clicking, the shadows will get much, much sharper because now the relative size compared to our shadow casting object is much smaller because of the distance that we have. And once we scoot it back, those shadows get nice and sharp again. And in terms of the disk light and the rectangular light, this is also dictated by the spread and the uniformity of our light rays. And if we were to use a distant light and point this in the correct direction, this would be affected by our angle because the distant light is considered to be infinitely far away. And so the angle is really how we control the relative size of this distant light. There's nothing super groundbreaking here, but I did just want to run through that again quickly. So the next thing I want to talk about is our intensity of the light, aka our contrast ratio. Getting these set up in Solaris and knowing whether or not we have a 1-to-1, a 2-to-1, a 4-to-1, and so on. And so if we go into Solaris, let's go ahead and turn off our metallic material here. And let's set up some lights on two opposing sides of our character. So I'm going to use let's just use a sphere light. We'll make it pretty big and we will put it at a distance of 2. And let's just kind of click on our left cheek here so we can look at that area. And right now the handles are actually in the way. That's why it's not letting me select. So I can hit Shift V and it'll hide the handles. And now I can just click on our cheek. All right, so that is our first light. We can just copy and paste this. And now with our second light, let's place this on the right cheek. All right, so now we have a contrast ratio of about 1-to-1. If we wanted to be a little bit more specific with it, we could go into our light properties here, copy and paste, just to make sure that we have the exact same thing happening on both sides, and then flip this light. So now we can be very confident that this is a 1-to-1 light ratio. And if we want to prove that, we have our little inspector drop down right here, and we can inspect our pixels. And let's go ahead, click and turn it on. And so now if we look on the left side of his cheek, we're getting a luminance value of about 0.55. That's where we're getting in the bottom right quadrant of this inspector. If we look at this cheek over here as well, we're getting about the same, about 0.55. So let's say we wanted a contrast ratio of 1-to-2, where this side is twice as bright as we have right here. So on our shadow side, what we can do is simply lower the exposure by 1. And now we have a 1-to-2 lighting ratio. If we were to view this, 0.55 and, 0.38, 0.37, depends where you sample exactly, you'll notice that that's not exactly 2-to-1. Why is this not reading like we expect? Well, we have a viewing LUT over top of our viewer currently that is showing us a skewed result of the real world lighting values. This doesn't show us light as it actually exists. It shows us light in a more aesthetically pleasing manner, which is how we should be viewing it. But if we wanted to measure the raw lighting contributions, we need to switch our LUT to raw. Now this is the raw lighting data, and now if we sample by his cheek, we're at 0.32 compared to over here where we actually start to get like 0.16. Now we actually have a true 2-to-1 lighting ratio here. It is because Houdini currently isn't smart enough to give us the underlying linear value. This is something that Nuke does, and it's a little bit of a pain, and so it's just something to be aware of as we start talking about and measuring contrast ratios. And so if I were to lower the exposure again, this is again going to cut the amount of light in half. Now this is 1-to-4, and we can just measure again. We're at like 0.3 over here, and when we go, we get around 0.75, so that makes sense. And really, this is why I like using the exposure slider as opposed to the intensity slider, because with every single full value we go up or down in the exposure, we will be doubling or removing half the amount of light, and it is very clear that it is doing so. That is compared to the intensity, where it's a little bit arbitrary. If we were to go from an intensity from 1-to-2, we would be doubling the light. But then if we were to go from, say, 10 to 11, now this is adding 10% of the light, even though we've just gone up one value. You can really use either or. I just think that the exposure scales a little bit nicer than the intensity slider does. There's really no requirement to use one over the other. That's just kind of why I prefer exposure. I know if I'm going up or down one value, I will always be doubling or reducing half the amount of light compared to maybe some arbitrary percentage. Another topic that I would like to bring up regarding the intensity of our light, because this will also have to do with contrast to some degree, is the sourciness of our light, the feeling of our light being close to our character compared to being very far away. And sourciness of a light is due to the inverse square law. Now, the inverse square law states that the illumination on a surface drops with the square of the distance. So let's say we are 1 yard away and we are getting 100% of our illumination. When we move 2 yards away, 2 squared is 4, so we're only getting 25% of our illumination. 3 yards away, the square of 3 is 9, so we're only getting 1/9 of the illumination, or 11%, and so on and so forth. And so when lights are very, very close to their subject, we're going to get a lot of intensity on the environments and subjects that are near the light. But as it starts to get far away, that light is going to drop off very, very quickly. And this fast drop off is what makes a light feel sourcey or not. Compare this to the sun, where everything is very, very uniformly far away from it from a cosmic perspective. So the general illumination that is hitting the ground is very, very even. That is one of the things that our distant light does, is it illuminates very, very evenly across our scene. If we were to change this to a distant light, and we were to use our handy diffuse placer tools, and we place it right here, let's maybe make this a little bit dimmer. But we can see it's illuminating our square very, very evenly compared to a, let's say, sphere light. Let's make this a little bit smaller. There's a very obvious fall off of the light as we get further and further away from it. And if we were to move this closer to our source, we can see just how bright it is at the head of our character compared to the fast fall off we are getting in the rest of our scene. Our lights follow this inverse square law, and so it is very important to be aware. We want our lights to feel the correct amount of sourciness when we're lighting, and the inverse square law is 100% what determines that. If we were trying to light a scene for the outdoors and we put our sunlight this close to our character, it's never going to feel right because the light doesn't feel even. It doesn't feel the correct amount of sourciness. So that's definitely a tool that we have to control the sourcey feeling, is the overall distance of our light to our subject. So definitely keep that in mind as we are lighting. And another technique that we can look at is using bounce light. In films, they use white cards or sometimes soft, warm cards to bounce light from their main source up into their subject. And that is certainly something we can take advantage of in Houdini as well as we are lighting. So let's take a look at that. It is very, very simple. What we can do is make another grid very quickly. And let's just make this maybe a 0.2. We want this one to be a little bit smaller. And now with this grid, we can bring this closer to our character. Do something kind of like this, just move it around. And this is going to act like a bounce on a film set. And so as we look right here, if we were to take our bounce grid away, and let's actually just name this bounce, just so it's a little bit clear. If we were to turn our bounce off, we would see that we are losing all of that illumination. And using bounce cards like this is interesting because we can apply a material to our bounce card, and that will affect both the intensity and color of the reflected light. If we make a material library and then dive into it, we can make a Karma material builder. We can just call this bounce material. And within here, let's say we want to tint this perhaps a little bit on the warmer side, and that looks pretty good. So we can go ahead and assign this to our bounce geometry. And once we do that, we see that our light is taking on characteristics of this now warmer card. If we were to dive into our material library, and let's just kind of look at our side right here, if we were to lower the overall diffuse amount in here, we can see that the intensity of our bounce goes down. So this is almost like the equivalent of a gray card right here. If we were to set our light brightness to 0.5, this is kind of a gray card. This turns into like a full white bounce card. And we can also control that pretty quickly with our base right here, but it just behaves as a nice bounce whose color we are able to tint very, very easily. Now, this card is something that we theoretically could replace with an area light, because doing this indirect bounce is computationally a bit more expensive. But using an area light instead of this card could potentially be tricky depending on the lighting scenario. So let's take a look at an example of that. Let's say this light is very, very vibrant. It is very, very much a purple color. And so the light is going to combine with our green and turn into blue here. That's something we could, approximate with an area light. That's nothing that's too hard. But then if we were to create a second light, perhaps this one is much more orange, and we kind of scoot it around. We can just use our diffuse placer tool to place it back here. Now we're going to be getting a mix of bounce colors on the side of our character. Coming from the front side, we're going to get a little bit more of this bluish tint, where we're going to get a more intense green from the back side. And we can see that reflecting on our character. So using bounce cards like this can be more computationally expensive to get in some nice indirect fill, but it does do a really nice job of color mixing and behaving like a wood bounce card will. So that is something to definitely keep in mind as we are trying to light in a realistic manner. When we look back at these references, they definitely had a warmer bounce card illuminating the underside of Margot Robbie, illuminating the underside of this character. You can really feel when there's a warmer bounce card being used compared to these, which are much more neutral in tone. This is all bounced lighting that we're seeing right there. So then let's move on to the inverse of bounced light, which is negative light, our negative fill. We kind of talked a little bit about how this works when filming. When we have an HDR, when we have a general environment, we can put gray and black flags around our character in order to help shape the light. So let's take a look at setting that up within Houdini. So go back to our character here. Let's just get rid of these and start with a dome light. Alrighty. So we'll go in here, we will pick a texture. Let's go into our assets folder, and these I have just grabbed from Polyhaven. Like I said earlier, I'm using this Mud Road Pure Sky here because it's a nice ambient light. So we'll just let that convert really quickly, and I also want to turn my bounce off. All right, so we can see that this is very, very flatly lit, like you would expect in an overcast environment. So if we wanted to add a little bit of shaping to this, instead of using a bounce like we have right here, let's turn this actually into some negative fill. And so in order to do that, it's very, very easy. We just need to get rid of all of the diffuse component and all of the specular component. Now, realistically, this would never be pure black. We technically would want a little bit of color on it, but we can see that we have now started shaping the light. We are cutting out the ambient light. When we take this out, we can see that we're getting a much darker and more dramatic shadow on our screen right side. So I think taking advantage of negative fill like this is definitely an underutilized tool of lighting within the 3D landscape. I think it really helps add nice shaping to your characters, and there's a reason that they do it in films and movies, and that's because you can really do a lot of work with just a simple black square. We get a lot of nice gradients, and that's just because this is blocking our indirect ambient light. There's not any bounce getting back to our character. And so that covers everything I wanted to talk about in terms of the intensity of our light and controlling that within Houdini. I think we've got them all covered. We've talked about contrast ratios, how we can measure them, sourciness of the light, negative fill, and bounce light. Now let's start talking a little bit more about texture in terms of lighting within Houdini. So texture refers to a couple different things. We have literal texture being caused by blocking the light, like we see in these examples here. Something that's really popular is cityscapes or trees. Blocking direct light and a little bit of ambient haze helps pick out those textures. We also have like the literal texture of the light on a flat surface itself. How does the glass that is potentially around the light shape it in interesting ways and kind of give us interesting colors? And also, what do lights look like when they are shining potentially down along a flat surface? How do they focus the light? Because this is different than the texture itself. We kind of almost have a double lighting effect here where it is mainly going down in this direction, but we also have kind of a secondary light spilling out this way, and there's tons of different combinations of lights that we can have as we're working. And so let's go ahead and start taking a look at these tools within Houdini. And so to start with, we are going to make a texture that looks kind of like these images here. Now, obviously, we could simply just use geometry that is shaped like this. It will certainly cast a shadow, but that is not always entirely necessary, especially if you can't see the source of the light, because blocking the light like this will have a computational hit, as opposed to using a light filter called a gobo. Now, what a gobo does in real life is it takes a black and white image, and where the image is white, it lets light through, and where it is black, it blocks the light. So this is what we are going to use for our little light we are creating. So let's go ahead and make a light. We'll throw this in here. And we can turn this into, let's say, a disk light. I think a disk light will work well. We can place it so it is affecting our character there. Then we can just turn up the intensity, normalize the power a bit, and we'll do something like this. Let's also turn off our bounce card. We don't need that anymore. So in order to apply a gobo to our light, we have this light filters tab here, and it is looking for a light filter that we have created that exists within our scene. And so in order to make a light filter, we need to make a light filter library. All right, so once we dive inside, it'll look very familiar to the matte context, and let's make a light filter. So we can see our options that we have right here. We have the gobo, which is what we are looking for. And we can see now that we have a light filter within here, we have a light filters primitive that is being defined right here. And within this, we have our gobo that we've created with this name right here. So all we need to do is go into our folder. We will grab our gobo. And then now we have that created, and we need to select it from our light. So we'll just select that guy right there. And now, if we take a look, we can see we have a very, very blurry version of our light filter. Why is this so blurry? Well, that is because our radius is rather large. If I make this radius smaller and smaller, our image will get sharper and sharper. And now as we kind of move this around, we can see the texture that is being projected through our light. And it's very, very handy. We could make it very easily look like we are under a tree. And it's just a really nice way to quickly add textures that you can generate on your own. We can just use black and white textures if we want, and we can scale the element if we want it to be bigger and bigger. We can also change it to where it repeats on the outside edge. And so now everywhere that we are shining, we have this kind of crazy circular pattern. And then from here, we can start to scale it down and have it repeat over and over like this. We can offset it. So gobos are very, very handy to use if you're trying to simulate, light shining through trees. And if we had some atmosphere in here, I bet this would also look pretty cool. So let's actually take a look at that really quick. We can make a fog box that is karma specific. And if we make this box, like say a scale of 10, as this starts to resolve, I'll click away from it, we can see we have a really, really nice light pattern going on. It takes a little bit to load up in the GPU, as you can see here, but once that loads, it should go pretty quickly. We just have to compile here. But we can see we have these really nice God ray patterns in here. We'll dive more into the Karma fog box layer, but I just wanted to quickly show that as an example of something you can do with gobos. They're really, really nice and fun to play with. And it looks like Karma is having a little bit of a hard time getting rid of that fog box. Let's just go ahead and click Restart Render to restart Karma XPU. And we'll just let this reload for a second. Great, now our scene is back up and running. So let's move on to the next type of texture we would like to create, which is a flashlight texture against a wall. Having little details like colors around the edges is a really nice effect if we ever need to shine something with a little bit more of a specific texture, something a little bit less generic. And so we can use textures in order to guide that. I have this texture pack here that I unfortunately can't redistribute, but I will show you which one it is because it is very, very good. It is this David Gruyere texture pack. It's like 30 bucks on here. If you ever find yourself in need of flashlight textures, this is a great spot to look for them. So let's go ahead and load maybe this texture 41 right here into our light filter, and we can actually use the same light filter gobo right here. And so if we just go to where I have that, which is a little clunkily on my drive, let me just grab this really quick. We have the flashlight texture. I'm going to grab texture number 41. It's going to load that in and convert it. Let's also change this to not repeat. We'll just do a single decal. And we can also turn down our dome light just to make it a little bit more obvious. So we can see if we start to zoom in here, we actually get our color information coming through our gobo as well. As I make this brighter and brighter, we can see we have those nice little details around the edge, these nice little blue rims, these nice warmer interior parts, and we're able to create a very nice flashlight texture using the exact same light filter node. So that is very, very handy. And now let's take a look at creating these sort of lamp shapes. When we have kind of unique spots coming out the middle, we can have lighter versions coming out the side. We are able to recreate these light shapes using what are called IES profiles. What does IES stand for? It's Illuminated Engineering Society. IES files are really just profiles of how light from a lamp is distributed within a room. And so we want to grab an IES profile, an IES format, load it into our light, and then if we load it up against a wall, this is the shape that the light will take. And we are able to find IES profiles pretty easily. If I just search IES profile, there's a whole library that we can start to look through and explore. If we go through browse, we can see all of the different shapes that are in here. I've included a couple of these, but we're able to apply any of these to our lights in Houdini. So let's take a look at that. So I'm going to get rid of our light filter here. We just have this light right here. Let's go ahead and change that to a sphere. We can make it a little less bright. And I do want us to have a wall to shine our IES light down. So let's go in here. We can grab our floor, copy and paste it, put it in line, and let's just rotate it 90 degrees. Now we have our wall, and we can start to move our light right here. And we can just have this at a very close distance to the wall. All right, so we have that light right up here, and we can see there's not too interesting of a profile at the moment. And so let's go ahead, remove this just to make sure there's no light filter bugs. And within our shaping tab, we have an IES checkbox right here. And so if we click that, we can find our IES profile. And let's go ahead and look at that. I have it in Assets, Light Filters. And we have two spotlights we can load in here. So as I do that, this doesn't look much different at the moment, and that is because we need to aim our IES light down. So let's just rotate this about 90 degrees, something like that. And it's obviously very, very bright at the moment. We can choose in the shaping tab to normalize it. And now we have that really nice IES profile shining down on our Han Solo looking man right here. And we can load in any IES light shape, and it's going to give us that really nice natural pattern along the wall here. It's a really handy tool, and I highly recommend using them, whenever you can. It's very handy when you have like a warehouse or something like that with these lights commonly lined up and down it, as we can kind of see in our reference photo here. This just adds another level of texture to the light and helps it feel more realistic. And we are also able to tweak the angle of our IES light with this little slider here. So we can very easily make it a little bit sharper and more narrow, or we can make it a bit wider. So big fan of IES lights when they make sense to use. They're a little bit noisy, as you can see here, and so I think that is the only drawback of using it. So you just kind of need to be aware when it is worth having an IES light versus when maybe it's a better idea to just use a standard light. So in terms of texture, we've covered most of what I wanted to talk about. And the next category I wanted to chat about is color, our handy dandy Kelvin scale right here. We can actually control the color temperature, aka the Kelvin scale, right here in Houdini. As we start to lower this, we can see it starts to get this nice warm color. Let me actually just pin this right here, mode always on top. And you can see that as we start to go down, we start to get those really reddish warm colors here. Most tungsten light bulbs sit around 3200 degrees, and then we can also start to simulate, very overcast daylight, more of like a neutral daylight as we go lower. And this is really handy just to try to match real color temperatures that real light bulbs use. It won't always be accurate because sets will use gels to tint the colors, and so it's really just more of a good starting point. But I definitely recommend trying to work with the color temperature scale when you are starting out. We are also able to use not only color temperature, but we can tint the color of our light with this color multiply right here. This will multiply the current color of your light by this value. If we turn off enable color temperature, we can see that we get the true value of what we select right here. So we can get some really funky light colors very easily. And it's nice because we can very quickly tint HDRs without having to dive into light filters. If we were to go back up and display our dome light, turn this guy up, we're able to tint this very easily. And that's something that was a little bit of a pain to do, especially in old Houdini. Using Arnold, you would have to reset it every time that you really wanted to see a change. And so I very much so welcome having this quick multiply available to us right here, exposed with our base properties. So this wraps up all of our basic lighting tools that we have available to us in Solaris. There's a couple more specialized tools when it comes to working with scenes, and a couple very unique circumstances tools that we will dive into. But in terms of our basic arsenal of lighting utensils, this is what we have to work with. So let's go ahead and start using them as we start to create our own shot, as we start to build the lighting from a story. Thanks so much for listening, and I'll catch you in the next one. Hello there and welcome back. In this video, we are going to dive into our approach to lighting a scene. We're going to create a story and take a look at how we can kind of analyze how to apply our 3 cinematic lighting principles. So let's go ahead and get started. So I have our project that we left off at the end of the 5th video for this week. We can get rid of a lot of this here. I kind of want to go back to where we were, where it's just our very simple HDR and our bomber in here. All right, and we'll make sure we have SDR video turned on our display. And so we want to light a shot. So the very first thing we need to do is to create a story. Like I said, the best thing to do is work from a story perspective and then go backwards from there. Without a story, we are just not really having a solid foundation to base our decisions on. So what story should we use? You can really use any story you want. And so the story that I want to use is a patient insect-sized drone hovers in the forest. waiting for its owner to come home in the late afternoon. I picked this story just because we'll be able to show some depth of field. We won't have to work with the background too much because if it's very tiny, we can have very shallow depth of field, and it'll just make things a little bit simpler for our very first shot. And since this is a full CG shot, we have a ton of creative freedom. We don't need to constrain ourselves to any footage, so really the world is our oyster. You by no means need to use this exact story. It's just something I made up. You can make up your own story involving just the ship on its own. I do think it's nice to make it small because we can really just focus on this object itself, but you can make up whatever you want. So we have our story. So let's just set up a quick shot for us to start working with. So I want to create a camera to start with. So let's click on our viewport with our mouse. And we can then control click on our camera in our LOP Lights and Cameras tab. And this will make a camera for us to look through. And we have our lock on, so we can kind of move this around a little bit. So I want to set up a little bit of a longer lens, and I always try to work based off real world measurements. So if I go into our view tab here, the first thing we should look at setting is our horizontal aperture. This represents the sensor size in width of your camera. And when you're working in a visual effects production, typically they will have a camera picked out and you will have all of your cameras match that sensor size. And so there's a really helpful website called VFX Cam DB. And this has a ton of cameras and will show you the sensor size based off the resolution you are working with. We actually shot a lot of the footage for this course on an Alexa Mini, so let's go ahead and use that as our sensor width. So we have that right here. This is the format that we shot the footage in, and so 26.4. Easy enough. We will enter 26.4. And let's also make our focal length 100. I want a pretty long lens, so we can just zoom out here and let's give ourselves a nice little shot of our drone. And I also want our aspect ratio to be a little more cinematic. So with this drop down, we can use the CinemaScope 239. This will give us a nice kind of slender box right here, and I really like the way that 239 looks. And I also want our ship to not have this landing gear. I want it to act like it's hovering or flying, so let's look at how we can remove those legs. Well, one way that we definitely could is we can find our landing gear right here, give ourselves a little bit of room, and we could turn this off. But remember, when we render to disk, this isn't going to apply. This is just for our viewport. So what we could potentially do is if we want to bake down all of our viewport overrides, we can go into this drop down right here where we manage our viewport overrides, and we can say create inline USD node from viewport overrides. And this will look at all of the invisibilities, deactivations that we have done in our scene graph and write them to a single node. And so we can just create that really quick. And now if we select this node, we can see we don't have the red dot anymore. It is actually turned off within our scene. It does it in a little bit of a complex way where it does it through USD code instead of something a little more friendly like a user interface. But this is certainly one way to kind of save all of your viewport overrides to your actual scene. That's a little bit too complicated for my taste, and so I think it would probably be easier to make a prune. We can put this right after our bomber. And from this prune, we can grab our landing gear and put that in our primitive pattern. Now we are just turning it off this way. And maybe it's a good idea as well in our OpenGL view to also turn that off. So we can also go into our proxy view. We can drag and drop our landing gear and add it in here. But now we have actually created the opposite problem because we replaced our render landing gear. So if we were to go back to our Karma XPU view, we would actually still have it in. So let's go ahead and use our selector here and make sure we have our landing gear, and we will control click our render landing gear. And now we can hit enter and now it will be gone both in our OpenGL and our Karma XPU. So you're probably thinking this is a little bit painful. It'd be easier if we could just have one switch and remove the landing gear. And the good news is we can. We can do that with variants and have that set up very, very easily, but I don't want to dive into variants until we're talking about assets in a little more detail. So for now, our prune will suffice. All right, so let's continue getting our shot set up. We will go back into our camera. We don't need anything too perfect. We could do maybe something like this, and it looks like I forgot to hit lock, and we will get our shot set up. And I think something like this will do for now. And let's go ahead and just collapse our scene graph tree. And it looks like I have accidentally favorited a couple things in our scene graph path. So this is a good opportunity to talk about favorites within our scene graph path. So if we have a very, very complex hierarchy and it takes a while to navigate to find exactly what we want, we can actually select a primitive and we can go ahead and add it to our favorites. And then even if we have our entire scene graph collapsed, we will see everything just loaded under this little favorites pin. And so if you find yourself running back to a few select primitives within your scene graph tree and don't want to dig through them, we can just go ahead and add it to our favorites tab just so we can access them very, very quickly. It's not actually changing the hierarchy of our scene. It is just a shortcut to those specific primitives. And so just for the sake of clarity, this scene isn't that complicated. Let's remove these from our favorites folder, just so there is no confusion when we are first learning about Solaris. Alrighty, so we have a very basic scene set up in here, and let's go ahead and grab an HDR to use. So our story involves the forest, so I just found this very quick HDR. There's not direct sunlight hitting the objects in the center, so I thought that this would work quite well. So I just downloaded this, and let's go ahead and load it into our HDR right here. And we will go into our HDR publish folder and load it in. All right, so I don't really want a bright, sunny background with this. I want something a little more neutral. So let's go ahead and just rotate this around maybe 45 degrees at a time until we start to get something that we like. That isn't too bad. Maybe we could do like 135, maybe like 180. I think something like 180 could work. 135 was also a little bit interesting. Maybe like 145. And let's go back to 140. I like the sort of gradient that we're getting across our screen here. We could potentially use this to motivate a little bit of light. We will need to be careful to make sure that it does not draw our attention. Remember, we are trying to keep the focus on our ship right here. But I think this is a great starting point for lighting our shot. I think we have a camera in place, we have a background in place. This is the composition we'll go with, and our job now is to make the lighting look much more interesting than it currently does. So let's go back to the story of our scene. A patient insect-sized drone hovers in the forest, waiting for its owner to come home in the late afternoon. All right, so let's talk about the narrative and emotional goal of this shot or scene. Emotionally, it seems pretty calm. There's not a lot of drama within this. This isn't an evil, ominous drone. And so I don't think we need too high of contrast. I think we can use some pretty soft light to just kind of communicate the friendliness of this drone. To some degree, it should look as approachable as it can because it sounds very friendly just by this description. So that is kind of our emotional starting point. And when it comes to the subject of the shot, that is clearly our drone. And we want to be careful that our eye is not being drawn to our background here. That's potential danger. We want to draw our eye more to our foreground. And we can probably do that with a mix of lighting and also using some depth of field, because remember, this is a small drone that we're going to play this as. And so if we really crank up the depth of field, I think that's going to help bring our focus to the front part of the drone instead of all of this contrast that is back here. And then finally, making this aesthetically pleasing. The best place to start with that is always having the camera on the shadow side of our lighting. But then where do we go from there? How do we determine how to make this aesthetically pleasing? Or maybe we don't even know how to answer the first question. How do I convey the emotion of my current scene? Well, the way to discover those answers is always reference. You always want to collect as much reference as you can of what you are trying to light, especially if you have any type of uncertainty. Collecting and analyzing your reference is the best way to learn about lighting as well as develop your own aesthetic taste. When it comes to finding reference, there are two websites that I absolutely love using. The first is shotdeck.com, and ShotDeck just allows us to search so easily for anything we need. We can search for drone, then we can search for forest, and it is going to start to give us different aesthetic views that we could potentially go down. You know, we have a drone in the winter forest right here. There's lots of great ways to navigate by genre, by the type of shot that you're dealing with, the shot type here. You know, we can just look at aerials, number of people, time of day. ShotDeck is really, really good for finding reference, and I definitely think gathering your reference and having a clear kind of idea going forward of what you're trying to do is so important. FrameSet is also another great website to find reference. I think with both of these websites, you can do like 10 searches for free before you have to do a paid account. But they're both excellent, excellent resources for finding references. And if you know, yeah, this was definitely in Blade Runner 2049, we can also very easily filter by the movie and see a bunch of great stills that have been selected here. And if you find one that you like, it's also easy to find similar shot types. And so a really, really great tool for gathering reference. But anyways, enough about these two. I love them so much. That's why I found all of these images. So now let's go back to our story and kind of compare our references and see what we like. So a patient insect-sized drone hovers in the forest, waiting for its owner to come home in the late afternoon. So let's just kind of look through these images and talk about what we do like, what we don't like. So this is of an actual drone, and you know, the red here I think makes it feel maybe a little bit more ominous than the feeling we are going for. And this also, just having a camera on here as well, makes it feel a little bit more spy-esque. So I think, you know, we can kind of throw these out as not quite matching our mood. I do like the soft lighting that we have in our character here. I like that, you know, it's not too dramatic. Maybe the blacks are a little bit deep for us. I do think the kind of reflection we're getting on the sides of these helicopters is nice. These seem a little bit too out in the open, and I don't want it really exposed to broad daylight. I like it to be a little bit more subtle. Something like this I think would feel nice, you know. And there was kind of another category that I saw where we have this very harsh kind of dappled lighting where maybe it's a little bit tricky to pick out your character without movement. And so, you know, this kind of goes in the same category here where it doesn't quite like fit the mood, but maybe we can do an alt on this story where it is more ominous. But I think this is also kind of interesting. It's a little bit maybe dark and moody, but I like the soft lighting characteristics. I think the God rays are a little bit too over the top for myself. And so that's really what reference is all about. You're going through the images you've collected that are, you know, in some way related to what you are trying to achieve. And you talk about what you like, you talk about what you don't like, and just see what really speaks to you as an artist that you think fits with this story. So now let's go ahead and go back and start applying our lighting principles to our image. Alrighty, so in looking at this, the first thing I would like to do based off of our reference, let's go ahead and minimize this window. All right, and we can also change this so that it is always on top. By the way, this is PureRef. It is a great program to use for collecting reference. You're able to download it for free online if you'd like, so I highly recommend using it. Just very, very handy to copy and paste images into and keep them on top of your screen. So I think our main references we're going off of is going to be this and this. We'll also grab, I think, This guy is pretty good as well. So these are kind of the refs we're going off of. So what I want to look into adding first is a little bit of like this rounded highlight to the top left. You know, we have this little motivational source there. So let's go ahead and look into shaping our light. So we have a little highlight on the top left and trying to keep our camera on the shadow side of our light. So we can go ahead and make a distant light and drop that in here, and that will create a distant light in our lights drop down, and we can just name this key light. This will be the primary light that we're using, and we can already see it is kind of pointing straight at our ship. Let's go ahead and just use our diffuse tool, and we'll click right here. And let's see what happens if we start to maybe get this a little bit brighter, something like that. And I don't really like the kind of sharpness of the shadows, so let's change the angle to be a little bit softer. I think this is too soft at the moment though. And so maybe what we want to do instead, let's use our shadow tool, and we will click here and then shift click over here. I'm trying to get this at a little bit more of an angle. I don't want it to wrap around the entire portion of the ship. I really just want it to kind of hit this left side. Now, I think something like this isn't looking too bad, but I do feel like we can probably do better, but I do want to save my progress with where we're currently at. So let's go ahead and look at a brand new tab that we have in Solaris, and that is the render gallery. So the render gallery is really, really nice because what we can do is we can snap an image of our current viewport. And if we click on this here and then change this to be tone mapped, we get a little snapshot of our current progress. And we also have the ability to see some render stats. Let's give ourselves a little bit of room here. We can also see, you know, how many samples did it take? How long did it take? What was the resolution? What camera did we use? There's some nice information here that we can kind of just look through and get a little bit of info on how quickly or slowly our render went. That is one of the many perks of using the render gallery. Those render stats only work in Karma, by the way. But another key thing that makes the render gallery great is, let's say we really kind of mess up our lighting. You know, we do something kind of atrocious like this. We change the color to something really bad. We change the exposure. We have the ability to revert our scene graph to what it was when the snapshot was taken. If we go ahead and right click, we can see revert this network to snapshot. And when we click on that, we can see it has reverted back to our original settings, and it now matches exactly as we had it in the snapshot. So it acts a little bit like a checkpoint. In case we make any major mistakes with our scene graph, we can always go back to a previous version. So as we try to adjust our key light to make it perhaps a little bit more interesting, we will have a nice backup in case we really go too far. So in looking at this currently, you know, we can kind of zoom in here without risking this kind of repixelating itself. I think at the moment it is all right, but I do want to try to get a little bit more sense of direction in it. You know, if we look at it currently, I kind of want it to mainly hit this upper section so that we get a nice gradient kind of coming down here as well. Right now, right here and right here are illuminated the same amount, and it's not doing exactly what I would hope. So let's go ahead and adjust that. So with our key light, maybe instead of doing our diffuse or shadow placement, we can do our specular placement and just select right there. And already this is kind of doing a little bit more of what I wanted. You can see there's just a little bit more interest and drama in this section over here. We're getting a nice angle. We can kind of break up the difference between this piece right here and this piece right here, where maybe they were a little bit flat beforehand. And so I think that's a nice touch. If we also look under the wing, we're getting a bit more of interesting shadows kind of coming from this side. Now we're getting a nice little gradient here that we didn't really have before. So I think just that quick little movement of putting our specular highlight there really is making this much more interesting than it was previously. So now we have our key light set in a way that feels pretty interesting to me. It feels motivated by our background, even though it strictly probably isn't realistic. Maybe we're getting a little bit too much glinting here, but it feels like it could potentially be motivated by breaks in the trees. So now I want to continue looking at our reference and seeing if there are any other ideas that we can kind of come up with to make this maybe a little more interesting. And so as I'm kind of looking at this character here, there's a nice little gradient on his jacket, kind of within both of these frames. And it again starts to feel a little bit flat, perhaps, at our bottom area. This is a flat panel, so to some degree that's going to happen. But I'm curious, if we added some negative fill within here, is that going to help our shading? Is it going to get a little bit more interesting and well-rounded and defined over here? So let's take a look into doing that. So I want to make a grid to use as a negative fill. Let me just turn this lock off so I don't accidentally move our camera. So let's just make a grid, and we can kind of throw it up here. And we can see our grid populate very quickly. If we go into our geometry spreadsheet, we probably want our grid to go within our lights because this is a lighting tool. So let's go ahead within our grid. And you can see that once I selected it, our scene graph path kind of disappeared. So to fix that, we could either pin this or we could check this button. And that is just going to always show the scene graph at this node instead of changing with each node that we have selected. So now we can very easily, put this in the lights tab, and then we can also say negative fill, just trying to stay nice and organized, and then $OS for the current name of this grid. And we can call this neg fill 01. Great. And so we have a nice little bounce board here. Right now, it is going to be adding light because it's just kind of like a lighter color. It's acting as a bounce. Let's go ahead and make a material quickly, and we can just assign it to our grid. We'll do a material library. We will dive into it. We will create a Karma material builder. And within here, let's turn the specular all the way down. And the color, something very, very dark. We don't want it to be pure black because nothing in reality is pure black, but we want it to be pretty darn close. So maybe something like that will work. And we can call this like neg fill. And as far as our location, let's go ahead and also throw it within here, just so that we're staying nice and organized. And maybe we can also put materials. Now it's very, very clear where this is going, and we can just very quickly, assign this to geometry since it's very, very basic. And now we have our very, very dark negative fill. So let's go ahead and take a look at adjusting this. Perhaps before we do that, we can even turn it off and we can take a little render gallery snapshot for ourselves. So we'll just take another snap. So we can see now when we try to compare these that our frame is shifting around slightly, and that is because we took these snaps when our viewport was a slightly different resolution one way or another, and that is why these are shifting around. So we want this to be more consistent. So let's go ahead and set up a node that will make our render resolution consistent no matter how big our viewport is, and that is a Karma node. And once we throw this in here, it'll create a Karma render settings and a USD render ROP. So let's go ahead and look right here. And we can see once we visualize it, there's a settings viewport engine mismatch. We want to make sure we're using the XPU engine. And now this is always going to render at 1280 by 536. And if we were to adjust this, say to 1920, this will auto adjust. And this little Python code here is saying, based off of our width, adjust the height based on our aspect ratio. And so right now with a 239:1, this is the correct height resolution based off our width, so we don't get any squishing or stretching in our render image. If we were to change this, say to 16:9, for example, we would see that this has adjusted to 1920 by 1080. So it kind of interprets the aspect ratio to give you a correct resolution. Let's go back to our CinemaScope widescreen. And for now, let's just do 1280. We don't need this to be super high res at the moment. I think it's more important to be able to iterate fast than see all the high details at this stage. And our viewport will be using these settings now. We took a look at the viewport settings earlier. We can see these are now grayed out because instead of using our viewport settings, we are using the new node that we have created. And if we go into our geometry spreadsheet, we can see it has made this render scope primitive that contain some render settings, render product, render var. We'll dive into these much more in a later video. But know for now, this is setting up everything we need to render out an image with our USD render ROP. It is looking for these render settings to render an image to disk. All right, so let's go ahead and get back to lighting now. We can go ahead and do another snap, and now we know that this will be at our correct 1280 resolution. And we can go ahead and turn our little negative fill light back on. All right, so let's go ahead and start placing this in a way that gives us some nice shading. I think right now it's a little bit too dark underneath our ship, and so I definitely want to look into tweaking this. So let's just make a brand new scene view in here. It'll be a little bit easier to navigate our negative fill here. So we can just go ahead and start moving this guy around. And you'll see when I had that primitive selected and I did that, it made an edit node. Instead of doing that for a transform, let's make sure we have our SOP create selected. And we could scale this up pretty big. I just want to see what it looks like as we start to kind of tweak some of the underlying values here. Like as we move this closer and closer, I really want to try to get some gradients around this area. And maybe I can angle it a little bit like this. Let's go ahead and look into scooting it over some. Maybe we can bring it more towards camera. I don't want it to get in the camera view, of course, but I am interested in kind of what we can do. What if I scale this up even more? What does this start to look like? Maybe we can roll it a little bit more this way. Something kind of like this. Let's go ahead and go into our render gallery and we can take a snapshot with our negative fill in here. Give ourselves a little bit more room so we can see. Now if we A/B with our negative fill, we can see the nice little gradients that we're continuing to introduce. You know, it's possible maybe this is a little bit dark at the bottom here. And so if we think it's just a little bit too dark, that's very easy to fix. We can go into our material library and we can just start to potentially raise the color of this to be a little bit brighter, and that's going to give it some more bounce. It's not going to be perfectly black like it is right now. Maybe we can go and do a screenshot of this. Let's go ahead and do a snapshot. And as we A/B, now we can see we're just getting a little bit more darkness at the bottom. We're adding an extra bit of gradient without going super, super dark, kind of like what we had before. So I think this is looking pretty nice in general. Now let's go back and just turn off our lighting adjustments. I always like looking at a before and after of shaping your light. It's always good to make sure you are making positive progress actually, instead of just adding a bunch of lights that make it look worse. So let's do a quick screenshot. So we can see that just with a single light and negative fill, we have shaped the light to be much more cinematic. It's not really super tricky to do with something like this. You just want to try to create those gradients, have the camera live on the shadow side, and try to pick out some nice highlight pings. So now let's dive back into our geometry spreadsheet and we can just clear our viewport overrides. So this looks like how it will when it renders. So I think the next thing that I want to do in here is start to place some lights, perhaps on the inside of this ship. I want it to feel perhaps a little bit more lively, kind of like there is just a little bit of intelligence or life within the interior here. It feels a little bit dark and maybe a little bit too ominous at the moment. And so in order to start placing lights within our ship, I think I want to turn the glass off so that we will be able to use our very handy placement tool. So we'll just turn the glass off temporarily. We can see how dark it actually is within our ship. And let's go ahead and make a brand new light. And this light, I actually want to go above the bomber because I want to put this light within our bomber primitive. And the reason for that is I want it to move as the bomber moves. If we were to apply a little animation to this, I want this light to stick. And so let's go ahead and place this light quickly for an example with our diffuse placer. We'll set the distance to like 0.05, sure. We'll have it be pretty close. We'll do a fixed distance, and let's make it a little bright, and we'll make it a sphere light, and let's just place it right here. That is a pretty big sphere, so we can make the radius even smaller. All right, so if we were to click away, we can see we have this sphere right here at the moment. And if we were to rotate our bomber this way, we can see our sphere doesn't move. But if we were to place this light within this bomber primitive, it would inherit that translation. Remember, this bomber primitive behaves similar to a null and it moves everything underneath it. So if we were to put our light within this bomber primitive and we were to also call it something like lights, and then we can just do $OS. So we name what the top is. We could just say bomber light 01. Now we can see our light lives within our bomber. And if I were to start rotating our bomber like so, we can see our light moves with it. It's very easy to attach lights to objects in Solaris this way. And the reason that I have the light up here is really just for organizational purpose. It lets me know that it's not part of kind of my main lighting group that is down here. This is something that is living within an asset, and so I just like that visual indicator. And so let's make this a nice like 3200 degrees for our color temperature. And let's start trying to place this inside of our vehicle here. I'm going to turn off our selection, some of these widgets. I want to be able to see what we're doing, and we will use our other scene view in order to kind of see where our light is at the moment. So within our geometry spreadsheet, we should also turn off our proxy geo just so we can see into there as well. So now within here, our proxy geo is also off, and we can go into our diffuse placement. We can keep this fixed distance, and let's start putting this light, somewhere down here perhaps. We can start to normalize the power so that it doesn't change the brightness. We can get our exposure up. Maybe instead of a sphere, we do a cylinder light. This is a little bit long since it's protruding out of our ship at the moment, so let's just maybe cut that in half. We can make our radius maybe a little smaller. Something like that, I think, is a decent starting point. I want something to kind of illuminate this underside. And so let's go ahead and just copy and paste this so it'll go in the same spot again. And for this one, let's look if we just start placing this inside of the car. I'm going to turn off lighting in this view just so it's a little bit easier to see. If we have something like this just illuminating the interior, I think it looks nice. It does appear that our seat is a little bit dark. If we want to zoom in during our render view, we can't really just do the traditional zoom because that will break our camera. But what we could do instead is with our camera view selected, we can hit this button, and then we will actually kind of see it locked through our viewport camera. It won't reset any of the pixels. So this is a good way to just kind of zoom in and look at specific areas if you would like to see more details, and you can reset with this button right here, but very handy for just kind of checking these details. So I think it looks pretty nice on the interior section. We'll see how much of this we really see once we put the glass back on. Maybe in our render view, we can actually turn that back on, but we can keep it off in proxy view. So let's turn our glass on. And we can see that maybe actually this is catching the interior of that a little bit too much. So probably something we'll want to tweak. That's why it's always good to look at these, with the correct context. And so if we go a little bit further back, let's see if we can try to get rid of that. If we have it over on our side, perhaps that kind of brings it down a little. Let's go actually directly overhead, something like this. I like that it's illuminating the seat. Maybe there's a little bit of contrast there. I would love it maybe if we could go a little bit further forward. You know, I'm just trying to place this quickly. I don't want it to rotate too much. Let's go ahead and keep our orientation. We'll place that here. And yeah, I kind of like that it's illuminating this seat. I do wish we had a little bit more lighting on this front section here. So perhaps there is a way for us to kind of cheat that a little bit. Let's go ahead and make an additional light. Copy and paste again. And, you know, this is probably going to look a little weird, but what would happen if we just placed it right here? Obviously, way too bright at the moment, but it is kind of an interesting look. And what I do really like about this, you know, if we make it nice and thin, perhaps a bit longer, is I think in our image, it is really going to bring your attention forward. You know, this is very much a subject separation point. Maybe it's a little bit too much attention. It's a little bit too bright. What if we scoot this up some? I just want to see what different areas look like. If we keep turning the exposure down, what kind of are we working with here? Once it's this dim, I'm not sure it is quite worth the effort. So let's try placing this in a different position. We can do a tiny sphere light, and let's see if we can just kind of stick it on the inside right around here. Something like this, perhaps. We can make it brighter so that it is actually causing some illumination. All right, and I think it's kind of interesting that it's catching this section as well. And so maybe something on the side could work nicely. What does something like over here look like? Maybe up to like 5. Let's see, it looks like we're catching a little bit of light in there. And let's also give ourselves some room. And we can just make one for the other side as well. And let's just Control F to kind of hone in on that. We're kind of like deep within our ship now. All right, we'll click on the other side, kind of have this in the same sort of area. Now we can see we're getting a little bit more wrap around this area, and maybe we want to change our distance so it's like right on this area right here, not leaning quite as far out. And we can see we're getting some more play in that center area. Maybe we'll want to turn it down, and this guy as well. We can just kind of scoot that in a little bit. So we have a little more illumination in this center portion, and it's probably not a bad idea to make sure that our lights here are in the exact same position, just on the opposite side. So I can just copy and paste these values and then flop this to the negative so that we are very confident they are in the exact same spot on both sides. And let's look into turning these down a little bit. I have them both selected. I just want a little bit of shaping in here, not a ton. I also think our seat is potentially a little bit too bright. It also contrasts with the fact that there's nothing else built on the interior of this ship. So let's go ahead and find that light. I believe it is this light right here. You know, just a little bit of light in here just to give it a little bit of character. It doesn't have to be super readable, but I think there's some interesting characteristics. I think that this is getting hit is kind of interesting. I like this little light at the bottom. It just makes it feel a little bit more lived in. And so let's go into our render gallery and we can just do a little snapshot here. And let's give ourselves some room. Let's see what we have done. So when we select here, let's go ahead and say that this is our B side. We can select this. This is our A side. We can very quickly wipe between the two. And I like the little bit of life that this lighting is giving to the inside of our ship. And the nice thing is as well, if we were to take our bomber and we were to rotate this, our lighting would also move with it. So it's set up very, very nicely. All right, so in terms of our lighting, I think we are looking pretty darn good. So what I would like to do now is look into adding some depth of field effects on our shot. Normally you do something like this in comp, but I want to show you how we could do it in 3D if we wanted to. And so with our camera 1 right here, which is what we are using to render, we can see that in this right here. We're using the camera 1 primitive. So let's select camera 1 and we will go into the sampling tab. And if we set our f-stop, our aperture, to something other than 0, we're going to start getting some depth of field. So let's change this to 1.8, and we can see we are defocusing our entire image. So that's not exactly what we want. Let's click on this show handle button, and what we can do is hit Shift F, and now we can shift click and decide what area is in focus. We can kind of see this line appearing as I'm shift clicking that shows you what area is the sharpest. And since we are treating this like it is a super tiny insect, let's go down to like 0.1, something that is very, very shallow. And so we can go ahead and click away here, and we start to see that very, very shallow depth of field that starts to make this nice and small. And we could potentially even like crank this further if we wanted to. It really depends how tiny we want it to feel. But now we are getting a nice depth of field effect, and we can see that our focal distance has updated when we do our handle selection. When we do our Shift F to turn on our focus tool and we change this, we can see the depth of field focus distance updates. So that is pretty handy. Now I think I might want to move this camera just a little bit. Something maybe kind of like that. Let's see here. I do think it makes our ship feel a little bit more interesting, seeing more of the back side of it, but it does make our background less interesting. So what we can do is just take our HDR and we can look into just perhaps rolling it down just a little bit, something like that. And we can always check our changes in the render gallery to make sure that we're actually making good changes. So we can change this to be our A side. And let's go ahead and just, quick wipe. I do think that little tilt did help, and most of our lighting was retained. I like seeing the back side of this. So I think that was a nice little adjustment. But yeah, I think this is looking pretty solid. Overall, this is around where I expected this to kind of end up looking. And we can look in our Karma render settings. If we want to try and clean up the sampling, the main way to do that is with our path traced samples. And so I always like working in multiples of 128 binary multiples. So we can try like 256, maybe 512. And if we give it some time, it should be able to clean our render up pretty nicely. This is an instance when we are using, depth of field that I do think it's actually a good idea to potentially turn on our denoising. So we can do that in the image output filters tab, and we can use our optics denoiser, and that will just clean up all of these little areas around here. Without that denoiser, it is very, very hard to sample in a way that is clean. And, as long as our samples are high enough, like 512 is probably the minimum I would go, it does a good job of cleaning it up. So let's go ahead and grab a snapshot of this denoised version. It's always good to do a little comparison with the denoised versus the non-denoised, just to make sure we're not losing any details, because that is really the worst thing that can happen is in eliminating the noise, you end up eliminating all of your details. So we'll just let this run for a bit and come back once it finishes. So now this render has finished at 512 with no denoising. Let's go ahead and do a snap and let's compare these. So it looks like our A, B are over here. I just want to do a quick little toggle. So I turned both A and B off by double clicking both of them. We can see there's no A, Bs anywhere in our viewer gallery. And we can just compare in here and kind of look to see if there's any detail that's going away. So it looks like there may be kind of some smudge detail on our glass that is disappearing. It feels a little bit denoised in there, but in this area, it's certainly significantly improved without missing much detail at all. So I think our answer is to up our sampling to something like 2048. That should get it pretty clear. This is probably going to take a couple minutes to render on my machine. Maybe that means yours will take like 10 or 15 minutes. And then we can do an optics denoiser on top of that. And we will be set and I think ready for a final render. So just a quick overview of the Karma render settings node. Up here at the top, we are able to define where our output picture should go. Right now it's going to go on our hip file /render. And it's going to go in this direction with the hip name, the name of this node, and the current frame that we are on. It's going to use this camera. There is our image resolution. In terms of our image output, we can adjust AOVs and add them within here very easily. We could add some combine diffuse, diffuse direct, our specular in here. There's lots of options for our AOVs. We're going to dive into compositing with AOVs later. For now, I'm fine with just using the beauty. And I think finally we'll change our resolution to be a little bit higher. We'll do like 1920 by 803, looks like is our calculated resolution. We can go ahead and pause our render view render. And let's go into our USD render ROP, and we can simply just render the current frame to disk. Before I do that, let's just pick a slightly better output picture location for our image file. So I like putting this right in our lighting folder. We can make an underscore renders. And let's just copy this path and then paste it right in here. And I also want this to have a $hip name so I know where it came from. And let's also put this in a folder that is named whatever this node name is. And then when we middle mouse click and evaluate, we can see that we are putting this in the name of the current hip file, and then the name of the current node, and then again, the name of the current node baked into the actual file itself. So let's change this and we can call this ship 01. Something like that should work pretty nicely. And now we can go in here and render to disk. So now we're going to let that render in the background, and we will go ahead and take a look at our finished render in the next video. Thank you so much for listening, and I'll catch you in the next one. Hello there and welcome back. In this video, we are going to take a look at our render and dive into our assignment for this week. So let's go ahead and get started. Alrighty, so I have Nuke open here. We will be using Nuke in addition to Houdini throughout this course to view our assignments, to do a little bit of work on top of our CG. So it is good to have, at the very least, Nuke non-commercial downloaded. It's free, and you'll be able to do most of the effects we're going to apply when it comes to adjusting our CG. But we're not going to dive too deep into anything with Nuke. We have a Nuke class at Rebelway if you're interested in learning more, but we're kind of just going to go over the basics here. So let's go ahead and bring our render into Nuke. I have our single frame here, and we can drag and drop in here, and it's going to create a read node. And we can view this by hitting 1 on our keypad, and that will bring up our image. Great. We can hit H to make it fit our screen right there. And we can see this looks quite a bit different than our render in Houdini. And this is where having a good color space pipeline comes into play. So within here, we are using aces. So the first step would be change our view to use aces. So we're going to click in our node graph, hit S, to open our project settings and go to our color tab. From here, we want to switch to using OCIO, and then we want to use ACES 1.3. All right, so this is certainly a step in the right direction, but we can see that our image currently looks very, very saturated compared to what we have in Houdini. And why is that? Well, that is because internally, this is currently using a different working space. If we go into our OCIO settings in Houdini, we can see our render working space right now is linear rec 709. And so let's try to commit that to our memory, linear rec 709, bring back Nuke. Within our read node, if we click our input transform, go to color space utility, we have this linear rec 709. And now we can see that these match perfectly 1-to-1. So it's important to make sure that we have consistent color settings as we are working and looking within Nuke. I'm going over color space briefly here, but rest assured we will be doing a deep dive into color space and how it all works and the underlying purpose of it in week 3. So now this looks like we would expect it, and we could do some comp tweaks to adjust this to make it look a little better. I don't really want to do anything at this point. I want to leave it raw. We'll talk about comping in a later video. So we did our very first ship render. That is excellent, and that is the first part of this assignment. Now the second part is that I actually want us to do 2 renders. I want us to create 2 made-up stories and light and render the exact same shot, the exact same composition for both of them. And I will bring in my alt render right here. And we can see there is a very different mood between 2 of these. And let's go ahead and also change this to utility rec 709. So very, very different mood and emotion that we are getting between these 2 images. And I tweaked this obviously quite a bit in the lighting department. And in terms of the story, this one I went more with the ominous insect-sized drone is hidden in the forest, waiting for its target to come home. I added a red light because I thought that felt ominous from our reference. I looked at this and added some dappled lighting so it felt a little bit more hidden, like it wasn't trying to be out in the open like we have in our image right here. And so that is what I would like you to do for your assignment. I want you to create 2 stories and have the exact same composition in both, but have the lighting communicate the difference between the description. And when it comes to presenting this, I actually want to kind of burn our story into our viewport right here. So we will do a text node, and this will allow us to just type in our text. And we can see that over the top here. We can select this, maybe make it a bit smaller, a font size of like 25. Let's make this a not gross font. We'll change this to Arial. And we can just drag and drop this to the bottom of our frame. And so this is our first story in this text node right here. We can copy and paste this into our other ship. And let's just also paste that text right here. And now we have our 2 different stories baked into our image. Let's go ahead and close all of these property tabs. And I'm just hitting 1 and 2 to cycle between these. And so I basically just want us to render out these 2 images to a PNG image for us to look at. And so what we can do here is make a write node, and we can connect that to our text. And we can go ahead and put this in a folder here. In 010, I have this comp folder. In our publish, we can do RBL3 010 image 1 version 1 .png. Great. And from here, we need to change our transform type to display, and this will now render out exactly as we see it in our viewport. And we can copy and paste this write node, put it over here, and we can just name this image 2. And then we can render this out. 1 of 1. Great. And then we can click render on this. 1 of 1. And now, if we look inside of our comp folder, what we should have is 2 images that line up with our Nuke display settings. And I have the viewport put in here. Then just put these in a zip file and upload them to the Rebelway website. And I will take a look and give you some feedback on them. So that is how I would like you to submit it. Just make sure when you're writing it out that we change this from color space to display, and that will ensure that our PNG looks correct when we are exporting this from Nuke. You by no means have to do the same story that I did or use the same HDR. Please make up your own and have fun with it. Gather reference, see how you can evoke the moods and the feelings that you have in your made up story, and see where that takes you. So that's what I have for you this week. Thank you so much for listening. I hope you enjoyed it, and I'll catch you in the next one. Hello there and welcome back. In this bonus video, I just quickly wanted to run through how I set up that dappled lighting in case you were curious, in case you wanted to know more. It mostly uses techniques we already know, but let's go ahead, hop right in and take a look. So this is the project I used to set up the dappled lighting. We're just going to run through and do a quick breakdown of it. So we have our camera set up, and to start with we just have two red lights on either side because I thought it helped it feel a little bit more ominous, and so that is nothing new. We have set this up before, and then we start introducing the HDR. And so once this loads in, you'll notice that our HDR doesn't seem to be affecting our ship at all. And that is because I basically wanted to use this HDR as our background. I didn't want it to contribute to the ship lighting at all. And how you can set that up is in this contributions tab. By default, this is set to a wildcard, which means contribute to everything. But if you change this to emission, this will have it just exist as the background, assuming that render light geometry is on. And so what I'm able to do with this now is if I take the exact same HDR, I can render this and control the amount of ambient contribution independently without worrying about the background getting darker or brighter. That is the only reason I really did this. In this Karma settings, I made sure I'm not rendering the light geometry, and I'm currently not setting any attributes on the contributions, which means it is going to contribute to everything. And so this is the only thing that I did that was brand new that I wanted to really go over and was the main reason I made this video. And so as we continue to go down, I'm pretty sure this is the exact same specular light that we made in the video. I just tinted it to be a little bit warmer because I thought it looked nice with the dappled lighting. And then we have our dappled light come in here that is just placed across our ship. I set up a gobo like we did in our light tools video, and I am including the JPEG that I used. It's really nothing too fancy. It just looks like this, and that is cutting out our light as it hits our ship, and it makes it feel nice and spotty, like it's being a little bit more hidden. And I used that light filter within here. I selected it and applied it to our light. And then I added a bounce grid instead of a negative fill. And I also tinted it a little bit green so we get a little bit of the feeling of the ground in here. I feel like that kind of helped it blend in a little bit more. So you can see I tinted this green, the specular is down to 0. So we're just getting a little bit of bounce on the underside of the ship. And you can see that makes a pretty big difference as you A/B, with versus without. That bounce really helps a lot. And then I did a little bit of fill at the front because I thought it was slightly too dark. I wanted a little bit of detail in there. So this fill just kind of fills that in a little, like it sounds. The fill is filling in the light. And that is how I set up this render. Nothing new in here at all outside of controlling the contributions of our HDR. So that's how I set this render up. Thank you so much for listening, and I can't wait to see what you come up with. Thanks.